All right, very good morning, everyone. Very welcome to this webinar, ROADVIEW webinar dedicated to CCAM cluster event. My name is Eren Aksoy. I'm the coordinator of the ROADVIEW project. I'm very honored to lead this webinar. Before we start, I would like to thank Mario, who is the main guy behind the organization of this webinar, and who is gonna be actually in the participant list. Yeah, he turned on the camera. Thank you, Mario, for setting up all this. We appreciate that very much. All right, let's get started. It's already 10:15. The agenda is very clear. We'll start with a bit of like introductory part where I will be talking about housekeeping rules, and then we'll start with the real sessions. Right. So just to be crystal clear in the beginning, this event is going to be recorded. So I would like to share the recordings on our ROADVIEW webpage, also on our social media channels. So if there is an issue on that, so if you do not want your interventions to be shared, please just simply email us, or you can directly chat with Mario, who is there in the participant list. So, and you can see the email here. You can directly let us know. We will take care of the rest. Don't worry about that. But this is we have done. This is the third session of this webinar series. So we have recorded the previous sessions as well, and we published them. Regarding the Q&A part and getting some direct feedback from you along the way, we have two dedicated boxes. On the top left, you will see the chat box, like indicated like that. You can notify us here in case of there is any technical issue that you are facing, but not for the Q&A part. Okay, if you have any technical questions to the presenters, please do not use this chat box, because for the Q&A box, we have a dedicated box here where you can pose your questions directly to the speakers. And you should also note that we'll collect all your questions and try to do our best to address them in the Q&A session. The speaker can also answer the question along the way. It's totally fine, but we will follow this session for now. So we have a couple of objectives when we organize this webinar, because there are many different CCAM supported projects, European Horizon Europe projects, and we just invite them to this webinar. So we would like to really get some interactions. So we would like to facilitate in-depth discussions on the current challenges facing the CCAM industry in Europe. Because when they proposed those projects, there were different types of challenges, but along the way, when they start working on the projects, I'm pretty sure they observed new challenges, or there are still unforeseen challenges that maybe we can discuss about. We would like to explore opportunities and success factors for the deployment of CCAM technologies. Most of those projects that we are going to listen to today are innovation action calls. So that means we are really targeting high TRL levels like TRL 7. And I think this is a very good opportunity for us to listen to each other about like opportunities and success factors to accelerate this deployment phase when it comes to realization of these innovations coming different CCAM projects. Of course, in each project, participants are having or gaining different types of experiences, different types of knowledge. So we'd like to foster knowledge exchange between those projects across the European Union and accelerate the use of CCAM technologies. It might be the case that different projects face similar problems, but came up with slightly different solutions. It would be nice to also listen to each other. We would like to also showcase the latest results from those projects. just to give you the landscape, so where we are and how far we are from those targets. We should also highlight the fact that some of those projects have just started, some of them are in the middle of their project lifetime, and some of them were already done. So it would be nice to see the project outcomes already now, even if they have like early results, so that we can see the level where we are exactly. Okay, those are our objectives, targets, while we are having this webinar dedicated to CCAM cluster event. If you would like to stay in the loop, if you would like to get continuous updates about the ROADVIEW projects, I strongly recommend you to subscribe to our ROADVIEW newsletter and event reminder using the link that Mario is going to share in the chat, or maybe he has already shared. Let me just quickly chat. Let's see the chat. Yes, thank you. Yeah. So you can also subscribe to our LinkedIn page, and we have a web page where we also release our publications, reports, public deliverables, videos. Likewise, we have the YouTube channel where we release our latest findings in the project. Okay, regarding today's session, yeah, we are right now here. We just started. I just give the welcoming words. Very soon we will start with the CCAM Association's vision in driving CCAM mobility in Europe, and Christian Merck is gonna talk from CCAM Association. And then we will have Christian is here, and very welcome, Christian, again.
Hello.
And we have also invited different CCAM supported projects from Horizon Europe. ROADVIEW is one of those. We have AIC award events, IntoCAM, and Podium. We will have a dedicated sessions for each of these projects, and we will listen to them, like how far they are, what are they really doing, and if there is any results that they can share with us, also share their experiences when it comes to challenges, opportunities, and all that. At sharp 12, hopefully we'll manage to have a lunch break. Around 1, we'll come back with a panel discussion where we'll invite all the speakers. I will be chairing this session together with Marzena. The panel discussion will be around like technical issues that we face, or experiences that we would like to share with each other, more technical things. Also, we will talk about a little bit about CCAM related hints, I would call, so that Marzena can guide the discussions to see how far we can, what are the expectations from CCAM side, CCAM Association, so that the projects can change their perspective a bit to meet those expectations from CCAM. So we'll frame the discussion in the technical and also non-technical aspects. And then at 2, we will have a session where we will show videos from different projects. These videos will cover findings, project results. For instance, any AI algorithm that does something, how does it work when we deploy it to a special vehicle or truck, or any agent. It could be also a robot. Right, and then we will conclude the webinar around 2:45. All right, let's go through the panelists. This is myself, Eren Aksoy. I'm the coordinator of the ROADVIEW project, and I'm chairing this session. And then we have Marzena here. I would kindly ask each speaker or the panelists to turn on the camera for a second, just to say hi. And we have Jan Erik, AIC project. We have Loha from Award. We have Beals from Events project. Cohen from CCAM project, and Vasilius from Podium project. Very welcome, everyone, and I'm glad to have you here on board. And I'm super excited. I think nice talks are waiting for us. Right. With that, we are done with the very first part. We can wait for any questions or comments if you have any for a minute. Mario, is there anything that I'm missing up to now? Do you think we are fine with the housekeeping rules and everything? Right.
Yes, I think we can move on to the
yes.
next presentation.
Then I will show the schedule, and is this still visible on the screen? Right. So the next session is about CCAM partnerships vision in driving CCAM mobility in Europe. Christian, I think the stage is yours. If you wish, you can start already sharing your screen. I will now stop sharing.
Yep, thank you very much. So I try to share. So can you see the screen?
Yes.
Okay. So first of all, thank you very much for the invitation to talk and discuss with you during this webinar. I'm Christian Merkt. Since May this year, I was elected CCAM chair. Before that, I worked in BMW in various positions. The last position was about vehicle safety, dealing with a lot of passive and active safety in consumer ratings. And this brought me finally also to the automated driving functions, because also consumer protection ratings tend to uptake this topic to inform the consumers about safety of these driving functions. So I'm here today to talk about the CCAM partnerships vision in driving CCAM mobility in Europe. So hang on a second. There is something here. Okay. The presentation consists of 4 parts: the role and vision, the collaborations we have, and the achievements, and finally we will have a Q&A, and yeah, and then we will, after that, we will have the pitch presentations at 11 o'clock. So the first overview consists of some key facts about our CCAM partnership. We are a quite new partnership from 2021. We have a budget about €1 billion, and we are at the half of the lifetime, so to say, of our partnership, hoping for a continuation in FP10. And we basically aim to explore the potential of cross-sectoral value, and therefore we bring stakeholders together. This is important. And finally, what drives us in the second half of the CCAM partnership is the continuation with large-scale demonstrations to support the development and also the market uptake, also create enhanced visibility to the societies, to the public. Yeah, to contribute to, let's say, our European vision and objectives that are displayed here on this slide. So CCAM is highly committed and contributing to the transition of the transport sector in the European Union for a safe and sustainable road transport, and this through automation. So this is our clear guideline, also in alignment with the European Commission and the member states. And the categories below are mentioning the competitiveness that is very much being taken up by the brand new Draghi report to regain economic strength and fostering competitive industry in Europe. Secondly, for sure, increase safety in road transport. When you think about the Vision Zero, going down or decreasing fatalities and injuries of the traffic transport in the traffic transport area. The third point touches the negative impact from road transport on environment, let's say through a better traffic flow management, the better usage of our transport means like rails and roads and so on. And finally, we have to integrate the weak and vulnerable stakeholder groups, persons, and let them enjoy the freedom to get safe and affordable whenever they want. This is one of the core aspects of the guidelines and the vision in Europe regarding CCAM solutions. Coming to the collaborations, it's important to mention that we have a high number of members. We are really proud of it. So that shows also a broad interest in the CCAM partnership. But even more important are the different entities where the members come from. So we cover basically all the important stakeholders like industry, research, universities, mobility and service providers, public authorities and road operators, and further regulatory bodies. Also the European Commission for sure is part of the CCAM partnership. So what are we actually doing in the partnership? The core task for us is preparing the calls with the European Commission, bringing our members together. We also discuss the SRIA, the Strategic Research and Innovation Agenda, how it will impact the next calls. Further, we exchange with other EU programs and partnerships like 2.0, Cities Mission, CHIPS Joint Undertaking, because we see them having the potential to accelerate and validate the CCAM strategies. And further, we collaborate intensively with other associations that are also CCAM members like AirTruck, our parent platform, or CEDAR, the European Road Operators Association, or CLEPA, the Suppliers Association, and further other important associations. Also important to mention is the states representative group consisting of the member states representatives from road authorities. They are important for the CCAM deployment and to contribute to our mission and vision regarding the public and infrastructure side. Finally, I would like to mention our CSA FAME project. It's one of our CCAM projects that is responsible for running a repository, consolidating the knowledge from all the CCAM and further research projects and activities. The internal structure of CCAM is clustered in the following clusters, and this was set up and built up when the partnership was started in line with the SRIA clusters, and it's important that we understand the needs and the societal aspects of the mobility, the key enabling technologies, also the requirements and risks of these fundamental technologies. Recently, we have new discussions of the software-defined vehicle, for instance. So this is all about the cluster 2, the overall transport system and their requirements, where also member states are contributing on that. And a further cluster is on validation of the safety of the systems, a very important item. And finally, the cluster 1 is dedicated to our large-scale demonstrations. I was already mentioning it. This is crucial for us to create a significant outcome also to the public, as we believe that the societal discussions about CCAM solutions are getting more and more important. Societal acceptance is a key for our mission and vision of CCAM. Regarding membership, what's in for members? First of all, it's clear we run CCAM as a platform, and it's an excellent information platform to stay informed, and for sure also to design and contribute for the calls for the projects. So this is one core aspect of a membership. And the second one is the strong networking character we can provide. You get easily access and contact to all these aforementioned stakeholders, very important and useful for most of our members from getting their feedbacks on that. And the third point is about the project's results. I mean, it's unbelievable how many research projects are going on in Europe and also worldwide even. And it's not so easy, honestly, to keep the overview about all these projects. And here we can also provide, or we provide a platform to learn about these projects' results. And important is to feed the results into the next updates of roadmaps or SRIAs. Then, for sure, as mentioned before, we drive some joint actions with other European partnerships, 2.0, AeroTruck, and so on. And there's always a possibility to join in these support actions. And also some national activities. For instance, we were also involved in the high-level dialogue in Ghent this year, summer this year. So it's always impossible. It's also always possible to really get your information you really actually need for your own projects and get the contacts and the network. And finally, the regulations and the standardization is crucial for the deployment of CCAM solutions. and they're also coming from projects results. We strive for contributing to the European standardization and regulation processes with our CCAM projects results. So here a model, a kind of model of collaboration with the CCAM projects in relation to the CCAM Association. So I would say the CCAM Association is the backbone and the platform that serves the projects and also the mission and vision of CCAM. We are organizing at least 3 big meetings a year where you can contribute, participate, or just listen. The association is furthermore the voice towards the European Commission regarding the common development of the programming. So the next framework program, FP10, for instance. But what we need is definitely the outcomes and the results from the projects that fill in the partnership with life and feed definitely into the new programmings or the updates of the 3Rs, etc. For sure, projects and projects representatives are always welcome to our networking events. Also, there are possibilities to present, and this, from our point of view, secures a very intense collaboration and communication, also regarding to member states and the European Commission. And as you know and mentioned before, FAME, the project FAME, is evaluating and collecting the results of the research projects in their database. So it's not a single outcome that is fixed or somewhere in the internet hard to find. FAME collects everything, consolidates, and also contributes to the programming. So this is basically our model, our cycle in regard to projects and the association. The achievements I would like to raise is basically the 3R and the 3R update in 2023. The 3R is the fundamental guideline that guides us through our research and innovation landscape. And even though the 3R should cover the full duration of the partnership in Horizon Europe, we do foresee the need for validity checks at least every 2 years against recent and ongoing developments, and also for sure research results. And this enables us to keep a kind of flexibility in our partnership and being able to react on the development of CCAM. Okay, so then here we have the project overview in CCAM clusters, and there's a mapping of our calls from 2021 until 2023, mapped and assigned to the clusters to give you an overview. So in the core here, again, the large-scale demonstrations with the MODI and Ultimo, meta case and mobilities for Europe. These projects address large-scale demonstrations and for the others, yeah, you will easily find out who contributes to vehicle technologies. Here, for instance, Aware, to all events, ROADVIEW, OptiPEX, AutoTrust. So these are the current running projects. And here is an impression of the timeline. So basically, the big harvest from projects results will come up next year, until end of next year. I'm not sure if you can properly read it, but I highlighted the ROADVIEW projects here in the middle. And also here you get the cluster categorization. And yeah, next year will be a very interesting, challenging, or yeah, a year also in terms of preparation for the next framework program 10. And yeah, I'm looking forward to that. And with this, basically, I'm at the end of my presentation. Here's some contact points where you can find us, or you can directly contact Margina or myself. And yeah, looking forward to the follow-up of this webinar. Thank you very much. And now we start for the Q&A discussion.
Thank you very much, Christian. Very informative. Yeah, in the Q&A, there is a question from Cormac McKay. Would you like to read it yourself, or should I first read it?
Yeah, hang on, maybe you can read it.
Yeah, I can read it now. Many European Union countries have not yet passed legislation to allow for autonomous vehicle testing and deployments, therefore excluding many from taking part in these projects. This is now under investigation by the Commission for unfair practice. So how close are we to moving European Union-wide legislation to that all members must adopt? And he is also providing a link which goes to thing. Cormac, would you like to elaborate more on your question, or I don't know whether you are still here? People are here. Vasilios is raising the hand. Maybe we can allow Cormac for. Let's wait for Cormac. Maybe he can elaborate more on the question. Would you like to unmute yourself and comment on that, Cormac? We can't hear you. Maybe there is a technical issue on this side. Vasilios was raising a hand. Maybe we can also pass him if you want to comment on that.
Yes, I don't know, Christian, if you want to, but I mean, if you can check on the FAME project that Christian mentioned, I can put here in the chat. I guess the chat is visible to everybody. You can see for every country, European country, the regulations and policy map, which pretty much provides you some what is actually the case in each country in the EU about the policies in order to set up, let's say, testing CCAM use cases. Pretty much for all the countries, because I was part of this research, all the countries have one way or another, let's say, somehow a policy. It's not mature enough. And I don't believe that there should be, or there will be soon, a European level legislation. But for each specific country, you can find, let's say, some guidelines on how you can set up a use case. The use case defines all the potential steps, defines who can participate. For example, in Greece, you need to have a research institute and a city authority in order to set up a use case. You need to have security driver, you need to have a remote operator. So there are specific steps in each one of them. These policies at national level has been updated in the FAME knowledge base pretty much a few months ago, so it's very updated, and you can find information there, and contacts on authorities, on local authorities.
I can join in there now if you can hear me.
Yes, now we can hear you. Fine.
Yes, so we'd love to take part in some of the Horizon programs there. Where available, but unfortunately, because Ireland hasn't passed legislation, we can't take part. And there is no rush to do so. So it left us with no other option but to report them to the Commission for failure to legislation.
Okay, interesting. Yeah, I thought after the Dublin conference, Ireland is pretty much.
Yeah, you would imagine so, but unfortunately not.
Dedicated to automated driving.
Yeah.
So
Christian, I can also confirm that Ireland is probably the only country that has no any legislation framework so far. But was there any CCAM-related call that required this kind of legislations? I honestly cannot recall. I don't know, Christian, if you can recall, or Aaron, if there was any call that does not allow you. But I mean, it will be difficult in any ways to set up one, anyhow.
To set up a position paper, or what do you mean?
Any call, if there is any.
If there was any call, any CCAM partnership call, or any other European Commission call for proposals.
Part of Horizon Europe, there was.
So Margina, correct me, but not to my knowledge that we had something specific on that from the CCAM Association side.
No, maybe what Cormac is referring to is some kind of projects with the demonstration activities, like we have in Ultimo, for instance, or in Modi, where they really try to do some demos on the streets. And then indeed, if there is no local allowance for that, maybe that could be problematic. So it depends in which type of projects you wanted to take part, because if it was really on demo projects, then indeed it could be.
Because we have no legislation, we can't take part in any. So we can't even make the application.
And do you know specific reasons for that?
There's been a wait and see approach taken. And that's why I think until we have a European-wide consensus, I don't think we're going to get anywhere.
I mean, from my observation, we have also in the CCAM topic different speeds in the European Union. Think about, I don't know, there are different speeds and awarenesses about CCAM solutions. To expect that the European-wide solution will be shortly in place is, I think, not appropriate in this case. So I would rather recommend to work specifically with the Irish governments or authorities.
I'm afraid the expertise just isn't there within government either. They just don't have the expertise and know-how to even draft the legislation.
Yeah, but maybe
what we can do is refer maybe to this new forum set up by member states for themselves for deployment activities of CCAM. The forum that the colleagues from the Netherlands set up, launching it in Ghent at the high-level dialogue. It's called Forum for Automated Driving, and member states plan to exchange best practices and how they allow CCAM on their roads. And this is really forum for member states to exchange between them and how to best go forward for deployment. So that would be the most useful in your case to encourage Irish government to participate in this and to learn from the others.
Yeah. I have very limited options, unfortunately.
We are promoting this at the SRG meetings, at the States Representatives Group of the CCAM Partnership, and there we sometimes have Irish representatives, so I can try to,
I was hoping after the TRA that maybe it might have been prioritized, but unfortunately there wasn't a huge showing at the TRA on autonomous vehicles. And there was no displays, unfortunately. So.
Yeah, probably for that reason that it was not allowed.
There you go. So it just there seems to be quite a conflict within Europe on the damage AVs could do to public transport, and many do not wish to proceed with autonomous vehicles at all. And that's a European-wide consensus.
What do you mean with damage?
Well,
physical damage or
no,
traffic management damage?
Damage to usership.
Ooh, what? Sorry?
Usership.
The usership, as in
of traditional public transport.
Oh, you mean that public transport is scared that their users will go away?
Yeah.
Is that the case?
Yes.
Okay, but there's, I think, a very good view of the different use cases there with automated driving.
Yeah.
That are actually not competing with public transport as such, because the public transport is a high capacity public, long distance basically type of thing. There's a hub and spoke approach that is being discussed, being the hubs are public transport and the spokes, the really narrow spokes could be done by automated driving. So they are not competing but complementing each other. But a very interesting study here is the Lisbon study. It's actually pretty old, but that describes the threats and the opportunities of automated driving in relation to mass public transport and these vehicles. That might provide some interesting guidance there on how to ensure that your traffic doesn't clog up in your city if you fully deploy mass with automated driving. So there are guidances there.
Yeah, it'd be nice to see an update with that, with actual deployments.
There have been several places where it has been verified that it is indeed true. Being in California, in Copenhagen, in I believe in Madrid even, on how to and how to not deploy mass and automated driving. There are some indications in certain directions on what you should and should not do. But there's not a consolidated version of that.
Excellent. Well, thanks for listening to me.
Thank you very much. It was a very nice discussion. Now let's see if there is another question. I don't think there is any more question. With that, we thank Christian one more time, and we just move on. According to our agenda, now we start with the European project pitch presentations. So we have ROADVIEW AIC award events into CAM and podium projects. So we start with that order given in the agenda. That means it's me. We can start with the ROADVIEW project. Give me a second. Let me just share my screen. All right, so we have more or less like 10 minutes for each project. And we start with ROADVIEW. Again, my name is Eren Aksoy. I'm the coordinator of this project. And ROADVIEW stands for Robust Automated Driving in Extreme Weather. And we started in 2022, so we are like halfway done with the project. We are in like month 25, 26, around this time. All right, so we have like 15 different partners from 7 different countries, European countries. We have partners from Sweden, Finland, Germany, France, UK, Turkey, and also one partner from Switzerland. And again, it's a 4-year project, and we are like halfway done. And our overall budget is about 10 million euro, including the contributions coming from the partners. And at the bottom, you see some of our vehicles that we use for our demonstrations. And so most of them are L4, and some of them are for only data logging. They are not doing anything about controlling. And some of them are used for only software tests and so on. And as you can see in this slide, we have another challenge, which is deploying our solutions to different vehicle embodiments. So we are not talking only about passenger vehicles, but also about trucks to be used in logistics, right? So this also brings another dimension of problem into the table. So we are also willing to tackle these kind of challenges. I'm pretty sure you have seen this kind of fancy videos on the web. When it comes to autonomous vehicles, there are so many investments in the field. So many companies are investing tons of monies and manpower to deploy their solutions to go from A to B in a fully autonomous mode. And you can for sure see this kind of eye-catching videos where the vehicle is really pursuing the environment in a nice way and driving, taking it from A to B autonomously. But we have to be careful because not every kilometer driven is equal. Most autonomous vehicles here have been primarily trained and tested under really optimal weather and road conditions with super nice and clear visibility. With that, what I mean is most of those demonstrations have been done under very clean and sunny days. But what if we want to now take those vehicles from sunny California days to challenging Swedish rainy conditions or snowy conditions? So ultimately, we will end up with performance drop. So that's the main challenge that we are trying to address. So ROADVIEW is basically addressing weather-related challenges by developing robust and cost-efficient embedded in-vehicle perception and weather-aware decision-making systems for connected automated vehicles with enhanced performance under harsh weather conditions. So our ultimate aim is to make those vehicles reliable and robust when it comes to bad weather conditions. So it's why we are unique is just because of that. We are not proposing anything about L5 driving. It's like we will not end up with L5 driving after 4 years. But what we propose or what we try to achieve is like how to make already available system more robust when it comes to these challenging weather-related conditions. And it's not only perception, but also the control side that we are trying to target. Okay, so we have 3 pillars in our project. In the pillar 1, we are generating synthetic data. We are generating data under control conditions in the simulator. Let's say. Okay, we have the digital twin software environment. We have the noise models coming representing the bad weather conditions, and we have the vehicle model, and we put all those in a simulated world to generate data as much as we can. And in the pillar 2, we have a bit more realistic environment where we have controlled rain and fog tunnels where we can emulate rain. We can generate rain in different intensity values so that we can, before we go to real domain in pillar 3, we can close this domain gap between simulated and real world, right? So this is our target. So in the real world, we have different vehicles. We collect data, we do quality check, filtering, and annotation, and then we send everything to our perception model where we do sensor fusion for the downstream tasks like free space detection, object detection, understanding the weather conditions, so that we can control the vehicle like by reducing the velocity or stopping the car and so on. And we are willing to demonstrate these innovations in the real world with different use cases. But before going to the deployment, we also propose to have X-in-the-loop validation testing, where we validate our solutions in a more control setup. So with this, our ultimate aim is to close important research gaps and collect data from various ODDs, use cases, operation domains, so that we can move towards the system at the TRL 7, where we really deploy our solutions, innovations to vehicles and show the performance on real challenging conditions. With that, we have different groundbreaking innovations. One of them, and one of the exciting one, is the early sensor noise filtering, where you can see if you have a LiDAR captured under falling snow conditions, you have, as shown on the left, you have a very noisy version, but after filtering, you have a very clean version, which can be passed to the subsequent downstream tasks like object detection and so on. And like in the TRL, we are also proposing data readiness level, which is basically about measuring the quality of the data. So how ready is your data for the deployment? Are you ready to start with this data to train your models, or is there any quality check that you can do quantitatively? Okay. And we are also proposing adaptive sensor fusion, where we are measuring how much each modality is contributing when it comes to different weather conditions. Maybe some sensors are more reliable than others in specific weather conditions. And we're also dealing with V2X communications, where the vehicle is interacting with the environment so that we can come over the cases where perception, onboard perception, is not reliable anymore, but you can get support from the infrastructure or from other vehicles. We have also, we are also dealing with the controller part. We are proposing weather-aware decision-making system, where the visibility of the environment or the slipperies of the road surface is passed to the controller to adjust the velocity accordingly. And again, last but not least, we are proposing X in the loop, weather-capable X in the loop system to validate our solutions before we go with the deployment in the real environment. So those are the innovations coming with the ROADVIEW project. And I would like to give some results, early findings when it comes to first pillar in this synthetic domain, where we generate simulated data. One of our partners have generated this simulator where you can, it's a parametric simulator where you can change the weather conditions very easily, increase or decrease the level of snow in the snowfall in the scene, change the vehicles and so on. In the context of ROADVIEW, we have also developed different digital twins of different test environments, because we promised to have one demo in the Arctic Circle in Finland, which is under snow, fully under snow. And those are the test areas where we create the digital twin, so that we, before we go there for the deployment, we can run some tests. We did the same for different test facilities in Europe in ROADVIEW project. We have in pillar 2, we have a bit more controlled environment where we emulate rain. This is the facility from Germany where we have sprinklers shown like here. We put the buckets here, and we have some sensors to measure the amount of rain and wind in this scene. So what we did is, in this control environment, we emulated rain and tested our best sensor suite. So we have a sensor suite where you have different camera, LiDARs, multiple LiDARs. You have 4D radar, and you have also thermal cameras to be tested when it comes to different amount of rain. And this is very unique, because this is already automotive graded sensors. This sensor ring, that means this sensor ring can already be deployed to a vehicle. But we have to do experiments when it comes to perception. So what we did is we recorded different rain conditions, and here you can see how it looks like for one of the cases, and you get different amount of rain here. And another unique thing in this work is that we develop an automated annotation tool, which is basically giving you annotation for each single point in your point cloud, like this is the LiDAR reading. Also, we have the 4D radar point cloud data. Now you know where the rain points are. Now you know where is the free space and so on. And this is super important when you want to model your noise raindrops or raindrops in the environment. And we are about to release this data set to the public, because it's very unique compared to its counterparts in the state-of-the-art literature. We are the only one that is coming with the dense point cloud, not only LiDAR, but also 4D radar. So it's a multimodal setup, coming with point-wise annotation for each data point in the dataset. Also, it is coming with different range characteristics to be used for additional purposes. And in Pillar 2, we have another interesting outcome, which is referring to the filtering. So we developed the fastest algorithm in the world, which is also unsupervised, so you do not need annotation. Compared to supervised counterparts, it is performing very comparable results. So on the left, you see real LiDAR data captured under snowfall in the US. On the right, you see how it looks like when you remove the snowfall. It is super important because we show that if you follow this fashion, if you do filtering first, your object detection goes up by 2% at least, or for some specific object detectors, without changing anything on the object detectors. Another results from the Pillar 3 is multimodal slipperiness estimation. Here I will talk about in the video session later, but here just to give you an idea, the vehicle is using LiDAR and camera and detecting this slipperiness estimation, information about the road surface by using this active sensor, optical sensor. This is used only for training network, and then as you can see here, network can predict about the grip coefficients of the road surface together with the uncertainties. Another, last but not least, another thing is about using V2X to control the, to use MRA, minimum risk maneuver, where the infrastructure is informing the vehicle about the slipperiness of the road surface and asking for having an emergency brake. And in this case, vehicle was going autonomously at 50 km/h. And now through V2X, we trigger it so that the vehicle can go to the safe road shoulder autonomously. We'll talk more on this when it comes to the video session, but it is to show you that the control part is also something that we are dealing with. With that, I'm done. We can take the questions in the very end, or let me just quickly check the Q&A if there is any question. There is nothing. So with that, then we can switch to the next presentation. I will stop sharing. Again, just a reminder, if you have any questions, please add it in the Q&A box. And the next pitch is from AIC. Jan is already sharing the screen. We cannot hear you, I guess. Are you muted still? Yes, you are muted. I would appreciate if you can unmute yourself.
So a lot of buttons to push. So if Microsoft is kind,
I can't hear you. I think you're still muted.
Oh, I can hear.
Can you hear me now?
Yes.
No, you are not muted. Is it me who cannot hear him, or Mario? Can you hear me?
I can hear you very well.
Okay, thanks.
Okay, then I stop so you can. Then I guess it's only you that have this issue. So let's start. First of all, I'm representing AIC. It is not a CCAM project. It is related to that thing. It's actually started earlier than this thing. So I guess that's why it's under the Penta framework. But it has very similar scope. It's a 3.5-year project that will end this fall. Stands for Artificial Intelligence Enhancing Vehicle Visions in Low Visibility Conditions. So it also covers driving of various automations, not just fully automation, but also ADAS in adverse weather conditions. And I think as previous speaker said that if we making a system work in fair weather is challenging, but unfortunately weather conditions in Europe is for at least half part of the world of the year it is rainy or snowy or foggy or other things like that, and we do want to have support in those conditions as well. So what we want to do is to extend the operational domain of various automation levels, automated vehicles in various conditions. It's coordinated by Mercedes-Benz, There are 6 countries involved, Austria, Canada, Finland, Germany, Israel, and Sweden. It's a fairly large project, 20 million euro, and with a 43 months runtime from mid 2021 until the end of this year. And it's basically trying to extend or working to extend. This is a very challenging project. It's not a digital one that you can go from no adverse weather performance to fully adverse weather performance in just one snap. But we are focusing on night, where you have reduced visibility, in fog, rain, and snow. And as an addition to the previous project, rain and snow is a very complex problem. Rain is not just the rain falling from the sky. Usually the main problem is rain on the road, and there is a vehicle in front causing spray, and that's a different problem than rain falling from the sky. And with snow, there is a large variety of snow, from very wet snow that basically can accumulate in front of your sensor surface to very dry, fluffy snow that becomes almost like a dust storm. And they all cause different challenges, and they have different sizes of particles, if you consider it also. The approach that we have then is various sensors from LiDAR, cameras, polarization information, and MIMO radar. And then we apply early on adaptive AI to enhance them. And then we go into on the system level on, again, system enhancement, resolution enhancements, using various computational approaches there, and very also high definition maps or augmentation, and then into a fused system. Another important part, similar also as ROADVIEW, is that we have a sensor simulation part and a scene generation part. It is adverse weather is such that it's very difficult to replicate the testing. Naturalistic testing is essential, but it's very difficult to have it repetitive. And if you want to do this type of testing, you need to find ways that you can have control over your testing, so you can compare different iterations of your system. We have a bunch of different partners. I think I don't have enough time to go into all of them, but it is coming from on the testing levels, device levels, simulation levels, technology providers on the system levels, and then to suppliers, and then OEMs. And we have 2 OEMs here, both Mercedes and Patria, which is a military vehicle provider. And that's also important that automation is applied to various areas. And here we have some pictures of different vehicles that we are using. I mentioned the Patria, that's an armored personnel carrier. To the right, we have, see if I can get my, and we have, I think, the main test vehicle here for Mercedes, and you see the sensor package on top of that thing. So I can guess that it hasn't been passed through the styling department of Mercedes yet. We also have another vehicle, a Magna vehicle, where we have a bunch of different sensors, and here's from a picture in a test chamber, and then you can see the same VTT vehicle that you had in the past on various testing. So here is the sensors that are used in the evaluation, and then to see the pros and cons of the different ones, and to find the best combination. From the top here, we have different LiDARs, both from Luminar and AEVA, but you also have a Velodyne. It's more like a reference. I think it's the most common reference point, even if it's not necessarily the best LiDAR. We have different cameras, stereo cameras, RCC blue cameras, and we have a prototype Bosch MIMO radar, and then we have a gated imaging, which is very interesting in terms of when you're imaging in weather conditions where you have a lot of particles in the atmosphere. And here are some examples also what you can do with in this case, the Magna vehicle here, where you have polarization, gated cameras, near and far infrared images, and so forth, thermal cameras. There's been a bunch of different test campaigns to collect data in various weathers. Northern Finland here, with Mercedes and VTT did some testing also in the US. We have done some in off-road conditions together with Patria. We have done it on other road conditions again here, and then you have also done I think the best the biggest test chamber available for adverse weather is actually in Japan, Yari, and so we have used that as well, and then we have also done again more winter testing. You can see the stylish umbrellas here also. So certain sensors, even if they are used for outdoor, when you have extreme weather exposure, it's better to keep them not so exposed. So if you want to have more information about the project, there is a website, aice.eu, and you can contact me also for further information. In the ROADVIEW, you also have VTT, so you have good indoor contacts there as well. And with that, I think I'm close, hopefully within time.
Thank you very much. Perfect with timing. I don't see any questions here, but maybe we'll collect them in the end and then go through those one by one. Now we continue with award, project award.
Hello, good morning. Can you hear me?
Yes, we can hear you, Laura.
Perfect. Then let me share my screen. Okay, a short introduction to award. It is one of the first flagship projects funded by European Commission on the use of autonomous vehicles in logistics. And as the name says, award is an abbreviation of all weather autonomous real logistic operations and demonstrations. We are 29 partners from 12 European countries, and the project started in January 2021, and it was finalized in June, so like 3 months ago. And the total funding we had was 26 million. So it's a huge project with a lot of expectation as well as achievements. In this project, we had multiple types of stakeholders included. We had sensor providers such as Navtec, Dasky, Foresight. We also had ADAS providers such as Easy Miles, Cerema, VTT, etc. But also we had HDV heavy-duty vehicle manufacturers such as Kamag, Terberg, Kion, and fleet management supervision and supervision such as Applied Autonomy. But we also had the entities that are providing fleet management systems to companies such as DFDS. And end users, we had 4 end users, DFDS, Avenor, Rotax, and Schenker, or DB Schenker, and you will see later on each one of them actually assigned to specific application or scenario. And then also we had lots of other entities with multiple acts, such as certification and providing the testing grounds. Mainly, we use the Digitrans testing ground for harsh weather condition, and other partners with transversal capacities, such as IRU, CARA, INIDE, that I am representing today. VTT, ITS Norway, Austria Tech, etc., who actually helped us with dissemination, communication, regulatory framework, business modeling, and impact assessment. As award is a really big project, it comes with 3 big ambitions as well. The first one is 24/7 availability of the autonomous vehicles under different weather conditions. So I'm really kind of connecting now to AIC project. Here also the goal was to enable operation under not only like day and night, but also under good and bad weather conditions. And we were targeting mainly foggy, rainy, snowy weathers where they have their own specific complexities. Of course, availability is one part, but also one of our ambition was scalability and replicability. So we targeted use cases both in confined areas, but also mixed traffic and public areas. And the idea was, or the third ambition was, to make sure that the vehicle is capable of operating under different scenarios in a reliable and secure way. So safety was one of the biggest ambitions of award, and we wanted to achieve the highest safety and security possible, and without any compromission of 24/7 availability and also scalability. The aim of award was to pave the way for the rollout of driverless transportation in a wide variety of applications, and addressing driver shortage and capacity utilization, whatever the weather conditions are. We had multiple objectives. I'm not going to go through the objectives. As you can also hear the objectives in the use cases that I will be explaining. So we had 4 use cases covered in the project. The first one, the heavy-duty vehicle was provided by CAMAG, and the site where we did the testing was Rotax or Divischenker site in Austria. And the demo started in July and was actually or continued till September 2023. So it was done previous year. It started and completed previous year. The second one, and this use case is on the hub-to-hub logistics. So goods were actually delivered from the Divischenker site, from Divischenker warehouse to the Divischenker premises. And then the second use case was for the airport. The vehicle that was used was provided by TLD, the Easy Tow, and the testing site was Avinor, the Norway airport in Oslo. And then the demo started in December 2023, and it was finalized in March 2024. The third use case was related to the port operations. The vehicle use was provided by Terberg, EasyTug, and the operation site was DFDS Vlaardingen site in the Netherlands. The test started in September and was finalized in October 2023. And the fourth one was the forklift use case. We actually used the trailer of Palfinger, and the trailer was automated by AIT, the research center, and the testing was also done at AIT's premises and testing ground. And the demo started December 2023, and it was finalized in May 2024, the last demonstration of the project, which just finished a few months ago. So the first one, now a little bit more details on the hub-to-hub case. Here you can see, I don't know if you can see my mouse, But on the top side, like the first picture, you can see the route taken for delivery of goods, as you can see from the warehouses to the Vishenker premises here and back. You have two routes, the green one and the yellow one. And in the middle, you can see actually that the truck had to pass through a public road. And in order to do so, we had to actually obtain some premises and also install some traffic lights. The whole test was done in 3 phases. The first one was major restriction to public traffic. The second was, so the focus was on actually what are the restrictions to public traffic and how we can solve them. In the second phase, the focus was more on optimization of the whole procedure under normal traffic. And the third phase was the extended operation with a standard driver. Initially, the idea was not to have any driver, but we obtained the permission only if a safety driver was onboarded. Later on, once we talk also about obstacles to autonomous vehicles, I would like to also highlight this. It took us almost 1.5 years to get the permission to drive from a restricted area through a public and mixed traffic area, because this is an highway. We had to also put like limited speed signs so that when the vehicle is actually crossing this highway, other vehicles actually are driving with limited, really low speed. And also there were some traffic signs, traffic lights installed so that sometimes the vehicles are not allowed to use the highway when the autonomous vehicle is driving. So it's not really easy nowadays to test autonomous vehicles, and in this case we had our own complications. We also tested operations with teleoperation in controlled environment, which also provided us lots of insights on how many vehicles can be actually controlled by one teleoperator. In our case, the optimum number is 5. And we tested actually also the acceptance of a teleoperator and what kind of challenges maybe teleoperation will bring. And also we did similar setups to this up-to-hub case in a more like confined area, and we tested the whole operation multiple times in confined area, like a simulated area, where we collected lots of data that helped us also to do impact analysis.
Yeah, just maybe you can report because you're out of time.
Yes, I'll try to be fast. So we did 38 days of testing, 20 days of testing on private area. We also did demonstration with connected infrastructure such as traffic light, gates, and weather station, which was also important. And the acceptance was kind of moderated at the beginning. Several traffic rule violations were actually done since we had this speed limitation and also the traffic lights installed. And we had only few days of bad weather conditions, so we couldn't actually collect lots of data to analyze the impact of harsh weather condition. But in general, it was really successful. In the second case, which is airport, we had this autonomous ground support equipment in the airport and the demonstration of an autonomous baggage tractor on airside in Avenor, Gardermoen Airport. In this case, this is the route that you can see in this image. The ground tractor had to actually get the baggage from here and drop it actually to the gate. This is where the airplane actually stops, so that it takes the luggage and then it delivers the luggage to the autonomous how it's called, where you put like the luggages. Now I'm under pressure. I have to kind of do it really fast so the words doesn't really come. So we had 10 scenarios tested, and we had different obstacles, cars, pedestrian, and we put lots of also artificial barriers to see how the vehicle behaves. The good thing about this use case was that we had lots of snow in the last phase, and also a lot of rain, so we could test actually the sensors under snow and rain and foggy conditions to give us lots of data on these scenarios. Yeah, we
But
did
maybe we can stop here, because otherwise we will cut from our lunchtime, and I think people will enjoy that. But anyhow, we can take the remaining in this discussion part, or the video pitches. We have also afternoon session, so you can also show your videos referring to those remaining 2 use cases, Loha, right? We can do
definitely, yeah. I will show some videos of
thanks a lot, right? Then just to use the time more efficiently, maybe we can continue with the events project. Bill, I guess we are still, because we have 3 more projects.
Yes, I will be very frugal in my presentation. Thank you for having me, Aaron. Hello, everybody. My name is Bill Rungas. I work for ICCS, and we are the coordinators of events. Let me share my presentation.
Let me just tell that events is the sister project. We got funded from the very same call. They funded only 2 projects, events and ROADVIEW. And we are both concurrently running right now.
Yes. Can you see my presentation?
Yes, but not in the full screen mode.
Wait. Let me see.
Right.
Now you should be able to see. Okay.
Thank you.
Events stands for reliable in-vehicle perception and decision-making in complex environmental conditions. Unlike, for example, ROADVIEW or, as I saw, AI for C, which are almost solely based on adverse weather, we have taken a route where we have, of course, adverse weather, but we also try to include also other, let's say, as the title says, complex environmental conditions. So some general figures for the project. We started 2 years ago on the 1st September 2022. We are a 3-year project with 7 million funding from total funding, and of which 5.5 is from the EU. The consortium consists of 12 partners, mainly from Western and Southern Europe. 2 are associated. So we have OEM, which is the CRF. We have tier 1 companies like Hitachi and Aptiv. We have research institutes and universities, SMEs, and so on. Here are our objectives. I will go very quickly through it. So it is, we have heavily based our work on the perception algorithms and on their design and implementations, using, as of now, 8 vehicles. We used to have 7, but here in ICCS, we have acquired a new vehicle. So now it's 8 vehicles. And of course, the second part of the project is the decision-making algorithms, and an umbrella for both is the perception self-assessment that then we want to integrate all of these packets. We want to integrate it and test it on our demo vehicles and on simulations. Then the last 2 objectives is of course to assess the impact of our project and be able to say and prove that we have extended the ODD in the use cases that I will present shortly. And of course, disseminate and be able to also have some inputs in standardization bodies. Now, to show some results, I'll start with showing, let's say, the basis of the project, which are the use cases. In this case, we have defined 3 use cases: the interaction with vehicles and vulnerable road users in a complex urban environment. The second use case is the non-standard and unstructured road conditions. And the third one is a low visibility and adverse weather. And based on these 3 use cases, we have defined 8 different experiments in which 1 or more partners of the project are involved. So to go quickly through it, the first one is focused on the VR use in complex urban environment. The second one is to reestablish a platoon formation after splitting because the platoon enters a roundabout. Third experiment is about self-assessment and reliability of perception data with complementary V2X data. Experiment 4 and 5 are closely related and are about decision-making for motion planning when faced with roadworks or unmarked lanes and when entering a highway, which is jammed. Experiment 6 is about small object detection in far range under adverse weather. Experiment 7 is about localization and perception self-assessment for advanced ACC and other vehicles behavior prediction. And lastly, experiment 8 is about driving on secondary roads under adverse weather. So these are the 8 experiments that we are currently running in events in, as I said, 8 different prototype demo vehicles. So this is our overall architecture. On the left, we can see all the, let's say, the inputs. This is maps, this is sensor and sensor data, and anything that has to do with communication, either it's an onboard unit or a roadside unit, which then feeds to the perception, let's say, layer, which of course include localization and data from all the sensors, etc., which then feeds to the decision making and motion planning, which also include the behavioral planning. And all this is actually connected with the self-assessment. So there is a real-time, let's say, self-assessment in an object level, object detection, object tracking, and localization. And the final layer, the final, let's say, component of our architecture is the control, the actuation, as you can see in this graph. So moving to some actual results. So we started with trying and succeeding to a large extent with generating data in simulation, so synthetic data generation, as also Aaron showed in his presentation. In this particular case, especially the bubble that's on the top, shows how we have taken a clean image, an image with a clean weather, and we, within the simulation, using machine learning, we have succeeded in creating different environmental conditions, rain, extreme rain, and also some snow. And this is completely artificially created, synthetically created in a simulation. Another important so far contribution is what you can see on the right of the slide, which is the creation of a new data set with different objects, road debris, from very small ones to much larger ones. And the idea is to be able to determine which of these objects are, it's not an actual English word, but it's a synthetic word, are overdrivable. So which object the car can go through it and which has either to brake or avoid, depending, of course, on, and this currently the collection has been done in good weather, but by the end of the project, data will be collected also on collecting the information of these objects also under adverse weather. Another very, very interesting work that we are doing is in object detection with 4D radars. Here, let's say the experiment is shown on the box on the bottom left, where due to rain and due to the droplets, different targets are created as ghost targets, so they appear somewhere that they are not. So as part of reflection. So using 4D radars, we are able, and by saying we, I mean one of our partners, not ICCS specifically, we are able to locate on the map the car itself, the segmented point cloud, and the detected object. So as you can see in the images on the right, for example, on the top image, there is a object, there is a pedestrian, VRU, that is detected, and on the bottom you can see the point clouds. Another really interesting work that we are doing actually in ICCS is the collective perception messages, edgy compliant CPMs. In this particular case, we are collecting, it's in an experiment about the roundabout that different vehicle enters and there are occlusions. So not every vehicle can see the whole scene. So each vehicle sends information about what they can see, their perception in an object level. And then using a Bayesian filter about occupancy grid, we can synthesize the scene with different probabilistic, for if you can see on the right, it's a grid, let's say grid-alike cell, that for each grid, we have a probability value of whether it is or not occupied.
Bill, can I also interrupt to wrap up? Because
yes, I'm actually done and wrapping up. So I will not go through this. I have put the slides just to show that we are, along with the technical work, we're keeping track of the different impact that the project is aiming. And just to point that we are collaborating with ROADVIEW, since we are sister projects, and with HiDrive, and try to exchange information and whenever possible quantify the different impacts of the project. So that would be, I hope I was on time.
Thank you very much.
Thank you, Aaron, and thank you everybody.
Then we move on with the next project into CCAM. Cohen, I guess you're still there. Maybe you can right away start sharing your screen.
Finally, all my, here we are. I shall be brief as well. I just noticed one of our trial sites is missing, so that helps.
Bill, I guess you're still somehow sharing.
Yes.
You should see
it's just blinking a lot.
Yes, trying to stop it.
Sorry?
Okay.
All right.
Okay, I think I managed.
Yeah.
You should see my presentation, right?
Yes.
Okay. Into CCAM, enhancing integration and interoperability of connected, cooperative, and automated mobility. This is just a brief introduction. I'm taking the honors for Professor Maria Pia Fanti, who is the actual coordinator. I'm just the leader of dissemination, communication, exploitation, and all the awareness events around it. So, at a glance, Horizon Europe, of course, Poliba is the coordinator, and the topic is the integration of CCAM services in fleet and traffic management, being how do we ensure that the potential or the opportunities that CCAM offers, how do we ensure that this is really truly linked to actual traffic management? So where the previous presentations were looking into the specifics of CCAM interacting with road and events, we are looking at the management part. So how can we manage all these vehicles that are coming up? It's EC funded, runs from 2022 November until October 31 in 2025. We have 21 partners in 10 countries. Demonstrations in 6 living labs. Well, I'll dive into that. The project has 3 main strategic objectives, being impact for society, so safety, environment, and inclusiveness. And particularly inclusiveness you normally don't hear. Safety, of course, reducing the number of road accidents, what the other projects are doing as well, caused by human error. Environment, reducing transport emissions and congestion by smoothing traffic flow and avoiding unnecessary trips. And that's more in the mobility and traffic management. And the inclusiveness is definitely mobility management. The approach, implementation and integration of physical, digital, and operational infrastructure. So these 3 are the main key with CCAM to ensure that it is really tied into traffic management. And in the end, we will be able to develop new mobility concepts for passengers and goods, leading to aforementioned benefits. So the physical infrastructures within each living lab, we have 4 leading living labs and 2 following living labs. The leading living labs are actually deploying stuff, and the following living labs in a lesser manner. Basically, you can have three levels, basically: dynamic dedicated lines, intelligent traffic lights, and intelligent road signs. Those are the main things where we extend the physical infrastructures. The digital infrastructures starts from what's available in the living labs. The living labs have CITS deployments available, platforms, etc. So what do we need to do additionally to integrate it in traffic management? And this is an overview of the things that we need to do. So first and foremost is how do we link fleets? Because individual cars is nice, but if you can manage fleets, you have a more profound impact on the traffic management part. Extended perception, as briefly mentioned as well. Data, of course, and that comes into CCAM platform extended server, which basically hooks into the CITS deployments. That makes it possible to create new services, for example, traffic balancing, by proposing alternative, less congested roads. That sounds like you can do this for anyone. We can do it currently as well, but it is load balancing. So half of the traffic go left, the other half go right. That's different from what's currently available. Freight transport and logistics is usually not hooked into traffic management, and we are creating some enablers for vulnerable road users. Now, innovative technologies, AI, digital twins, V2V algorithms for controlling intersections and platooning. That I don't need to explain those, I expect. And then we come into the operational infrastructures, because in the end, you're not integrating technologies, you're integrating organizations. That means there should be governance models, and these organizations are the ones that actually execute the trips or actually manage the trips, the traffic, the fleets, etc. So that means that we need to integrate these operational infrastructures as well towards urban planning, urban economics, to ensure that every stakeholder is involved in the collaboration. In the end, that leads to business models, because there's only collaboration if you have a business model for automated shared vehicles, and of course for interoperability and the integration of public transport. If there's no value to be shared, then there will not be any integration. And again, this leads to the achievement of the integration of CCAM in the entire mobility system. So this is an overview of what I briefly mentioned, complemented with the 6 sites that we have: Tampere in Finland, Trikala in Greece, Turin in Italy. That one is missing in the slides, I noticed. Vigo in Spain. And then the follower living labs, Bari and Quadrilatero in Portugal, which actually is a combination of 4 cities. Underneath you can see the key things they are doing, but I'll briefly run through the living labs themselves to have a better view. So these are the ones where you can see it. Trials run from April 2024 to March 2025. So that means that we're smack in the middle of the demonstration period. That also means that I have no consolidated results for you to share, because we just don't have them yet. In Tampere, what they'll do is an interesting one is the combination of such an automated shuttle with public transport. We briefly discussed it earlier, but there's a combination there, and an automated shuttle should not interfere in the trams operation. That's one of the things. Of course, we have GLOSA, and there's another one that we have available. In Trikala, it's a remote control using 5G, 4G. What they try to do is having a fleet of pods. Currently, this fleet is not yet these true shuttles, but they are manually driven. So it's an operational fleet. And this operational fleet, in the end, is able to be spread if they apply our tools. The pod itself is also attached to the site. But there are some things that are added, for example, an emergency phone line, emergency button, giving the availability to smooth the braking of the vehicle. But not only that, if you have an emergency phone line in such a pod, it is very useful for the inclusiveness. Real-time alerts, fleet management of real-time monitoring of bus positions, events, etc. That was what I mentioned, the link with the traffic management center and being able to spread the traffic. In Vigo, there's it's a very extended site, actually. There's a dedicated into CCAM lane, and basically this lane is enabled or disabled when traffic conditions allow. So you enable or disable automatic driving in a certain area. This will be done in an operational trial, an operational demonstration as well in November. So it's a little bit too early. Trikala and Tampere already had their demonstrations. Next to each trial, we do a demonstration including local stakeholders. The next one is in Vigo in November. mentioned, Turin is missing. And what they're doing there is working with UVARs and hooking up these UVARs with the current way of sharing traffic information, so DATEX, but also through automatic vehicles in a direct communication manner, together with an automated shuttle. So this automated shuttle can hear if it is allowed to enter the UVAR or not, making it possible to change routes, reroute, to take a different entry into UVAR. Then the Follower Living Lab is in Bari, developing a simulation of a route planner. That sounds a little bit simple, but this is basically an automated delivery fleet. To get the other one underneath. It allows for moving traffic to other directions, plus the automated delivery fleet are small drones that run over the sidewalks. So instead of needing to run from A to B with a truck and the packages every time, you just go to a central place and just send the pods out to see if that's possible. That's one of the use cases there. In Quadrilatero, they're trying to figure out if pricing incentives can help to reduce traffic in some areas. It's an urban platform they already have available, so they have a lot of information, traffic flow observations, incidents, weathers, and building. They have a lot of information there, real-time data, and they want to see if they can work with pricing and off-street parking spaces in a simulated manner only because it's a Follower Living Lab. Next step will be the final implementations, demonstrations in the field, of course, the data collection, evaluation, and then the impact assessment, in which we will have the output and the outcomes of the project available for you. Evidence-based guidance indeed, and policies and regulatory recommendations for the CCAM services was already briefly discussed, but we also suffered the pain from different regulations within different countries regarding the timelines of implementation.
Thank
If you want
you.
to know more, scan the QR code, I would say.
Thank you very much for the interesting talk. And we can move on because you have just like some minutes left. Vasilios, maybe you can start sharing your screen for the podium project.
Yes.
Of course, we'll be fair. You'll have 10 minutes.
Yeah, I will do my best to save some,
no worries.
some minutes.
Take it easy.
Yes, I think you can see my screen, the proper screen. Okay, good to know.
Yes.
Good evening to all. My name is Vasilis Surlas. I'm one of the managers in the podium. We're in the middle of changing the coordinator person now. That's why I'm presenting the project today. The podium stands for the physical and digital infrastructure connectivity and cooperation enablers, building trust and sustainability for CCAM. A few details about the project. The project was part of the D60103 call of back in 2021. It is the sister project of the augmented CCAM project. It is comprised of 26 partners coming from 8 different countries with a total budget of 12 million euros. It has a duration of 36 months. It started in the October of 2022. So now we are closing the 24 months and we are in the process of deployment before starting the demonstrations and the evaluation part of the project. The idea of the podium project is to build on using and enhancing the facilities of 3 well-equipped living labs in 3 different countries, in Germany, Italy, and Spain. In some of them, we have also dual, let's say, sites. We define a rich set of demanding CCAM use cases to identify and assess all the connectivity and cooperation enablers and needs that will allow the proposed high levels of automations in each use case. The proposed use case, building on these proposed use cases that spans between urban and highway setups, will be demonstrated and validated in real life conditions. And the idea is to tackle the different requirements for availability and performance of connectivity, as well as the different cooperation enablers per use case. The idea pretty much of the proposal and the call actually was to advance a set of key technologies both in the physical and digital part of the infrastructure. In order to do so, an advanced multi-connectivity approach is followed. We are advancing multi-access edge computing as the enabler of these new use cases to allow extended and more detailed data fusions in order to enhance environmental models. For specific use cases, we extend given CITS messages, and a good portion of the proposal is about to ensure software integrity and trust and truthfulness of CCAM data. This is not a cyber secure part. I mean, we are not trying to handle, as in the Connect project, for example, malicious users, but for misbehaving sensors or misbehaving software or hardware that due to a vulnerability or due to a faulty system sends data that cannot be trusted. One important part is the integrations of the vulnerable road users in the whole ecosystem, both as a source of information, but also as an output, let's say, of the project on how to inform them about potential risky situations in parallel, let's say, with the AVs. One of the initial outputs of the proposal was of the project was this three-layered podium reference architecture. It has three layers that are well known. It's the cloud layer where the global data management can rely. It's the edge layer where we have hybrid data management, so data can be handled and processed and produce, let's say, hybrid fusion, both in the edge part or in the cloud part, depending also on the needs of the specific use case, but also on the capabilities of the corresponding deployment. And of course, we have the road level. In the road level, you can see any kind of interactions between all potential road users. You can have from fully equipped autonomous vehicles. You can have legacy vehicles that has zero, let's say, connectivity capabilities. You can also have VRUs that are connected through their mobile phones, but are also, let's say, using the road. And you can see different here. You can also see different arrows with different colors, which showcases the different communications technologies that are deployed in the different sites of podium. In this here you can see it a little bit more detailed, the different, let's say, connectivity options. We have deployed, let's say, traditional single connectivity that can be done either through the cellular network or through the side link, the ITSG5 and the short-range communications. But as you can see here, we have also facilitated different technologies in each case, from 60 gigahertz Wi-Fi short-range communications to the well-known ITSG5, but also to different frequencies regarding the 5G wireless, from centimeter wave, that's the traditional 5G connectivity, down to 5G millimeter wave. The idea here is to showcase that, of course, it's not the case that all the road infrastructure can have all the potential capabilities, but the idea is to showcase that you can use different options based on the needs of its use case. In the use cases of the project, we use also hybrid communications, which means that an entity can use more than one, can simultaneously transmit more than one, using more than one, let's say, interfaces, but also multi-connectivity, which is a little bit more difficult from technical perspective, because here you can schedule messages and data packets over different communication technologies. For people with networking background, this is more difficult, let's say, because at the end you have to reschedule and put all the messages in the right order. But this gives you, let's say, some security on the fact that at the end you manage to take all the needed quality of service from the network. In this picture, you can see pretty much the functional view of the different services and, let's say, actors that are part of the Podium project. You can see here the risk management, the digital twins that can run either at the cloud or locally at the edge. For example, in a tunnel, we are assuming that the digital twin managing the traffic there can run at the very edge, down to the specific sensors and actors that needs to interact with all those services. As I mentioned at the beginning, we have 3 different living labs, one in Germany in the city of Ulm, which is a totally urban environment, having different technologies deployed. For example, the 60 gigahertz Wi-Fi can be found here. We have a living lab in Spain that spans 2 different areas. One area is an urban environment, and the other area initially was a cross-border corridor between Spain and France due to various, let's say, limitations from we had to change this area, but still we managed to let's say emulate this cross-border facilities in a different area close to Barcelona. And also we have a living lab in Italy, which is also a dual living lab, one at the complex intersections in the city of Turin, and one in a highway tunnel located in the Autostrada del Brennero. Most likely in the follow-up session with the discussion, we can probably discuss some, let's say, limitations or policy limitations that had an impact, at least in Podium, in order to perform the necessary tests. In this picture, you can see pretty much the whole ecosystem, how complex it is. The Podium platform is the Podium reference platform architecture, and you can see how all these different entities, from the end user to the vehicle manufacturer to the external software providers or the hardware vendors, needs to interact. You can see their relationships and the potential service delivery options. It's a complex environment. I mean, if you top on that, the difficulties presented in the different projects, including different scenarios due to different weather conditions, you can understand how complex the CCAM ecosystem is in order to perform any potential tests and demonstrations. This is pretty much the presentations. I don't want to spend more time from the break. We are now, as I mentioned, in the process of deployment of the technologies in the different living labs and test sites. And later on, after the Christmas, let's say, period, we are going to start deploying the demonstrations. And note also that 1 or 2 of these, let's say, technologies will be deployed and presented in the following EU CAD conference, I guess, together with some demonstrations from the other projects presented today.
Thank you very much, Vasilis. Lovely.
Thank you. You can also see here some social media links. Yes.
Yeah, with that, we are actually done with this session, and we can have the lunch break. But there is only one question, and I think it is relevant to your project mainly, but it's a general question to everyone. Has anyone used or seen Wi-Fi, light fidelity technology in
no.
V2X communication? As far as I know, many we are using cellular technology, right? 5G.
Yes. In our situation, yes, this is an option we haven't considered as well. We have also not considered the non-terrestrial, let's say, connectivity. If the project was written today, the proposal, and not back in 2021, probably another connectivity option as the satellite could have been included. The Wi-Fi honestly seems like a nice idea, but I haven't found it in any of the projects, but it sounds like another potential, let's say, solution.
Thank you very much. With that, we are done. We thank all the speakers, and we are gonna meet at 1 Central European time at 1 o'clock. We are gonna have the panel discussion then. All right. Welcome back, everyone. We are not that many yet, so we missed like 15 people. I assume they're still enjoying their lunch. Maybe they will join a little later, so we can now get started. So according to the agenda, we have now the panel discussion. We'll be discussing current CCAM barriers, success factors in the EU and research and innovation landscape. For that purpose, I would like to ask each presenter to turn on the camera, because it will be kind of panel discussion among the presenters. And I will be chairing this session together with Marzena, by the way. Thanks a lot. Loha, may I also kindly ask you to turn on the camera if you're around? Maybe you will join later. All right. We can start. Yeah, thank you, Loha. Yeah, we can have 2 sessions like where we talk about mainly the technical issues, challenges, and opportunities, and also we can talk about CCAM-related opportunities, mainly about the standardization, regulatory aspects, and so on. Yeah, let me see. So maybe we can first, we have four subtitles for shaping this discussion. The first one is CCAM barriers to technological advancement. So I can pose the following question and then we can like ask each of you guys what you guys think about that. So what are the primary obstacles CCAM technologies face in achieving widespread adoption across Europe? So let me elaborate more on this question. Mainly this is for podium project and also in CCAM because you guys have more living labs across different countries in Europe. And when it comes to spreading, when it comes to deployment of this thing across different countries in Europe, what kind of primary obstacles, primary challenges you faced when it comes to the CCAM technologies that you are developing? So I don't think it would be super smooth to go from one country to another and deploy the very same technology there. Is there anything that you can comment on? Maybe we can start with, I don't know, Vasilis and Cohen. I mean,
yes,
we just take it like easy, okay? I don't think
yes,
I have to force anyone to say anything, but let's see.
I think there are tons of obstacles. Otherwise, there would have been no reason to have research projects and research proposals and have the CCAM partnership working on this, which I guess you always need a problem if you want to do some research. An important thing, for example, I'll just give you an example for the podium use cases. One of our use cases has to take place in a tunnel in the cross-border in Autostrada del Brennero in Italy. The idea there is to examine high precision techniques, excluding GPS, in order to have, like, let's say, precise positioning. And for these reasons, we needed to have a long tunnel in order to make sense. So there was a new directive, let's say now in Italy, that all the tunnels more than 500 meters need to have, let's say, something like an ISO standardization, a similar technique, which means that any time that you want to add some new infrastructure, then you need to go through the whole process. And for example, this was a major, let's say, obstacle in order to perform the demonstrations and the activities that we wish to have, let's say, in the tunnel. Of course, you can find countermeasures. One countermeasure is to find a slot when we have, let's say, services on the tunnel, to find a smaller tunnel, but smaller than 500 meters. I mean, still the GPS is present and there is not enough time to examine. A similar, let's say, issue also arises in the cross-border corridor between Spain and France. Because I mean, deploying infrastructure from a small project, it takes a lot of money and a lot of resources, and you usually are based in a previous one or some, let's say, already deployed commercial solutions. And this thing at some point has some issues. I mean, you cannot, a mobile network operator cannot provide you the necessary, let's say, quality of service in order to perform your solutions. You cannot always find a dedicated lane if you wish to have a dedicated lane for the autonomous vehicle. You cannot examine high-level autonomicity because the driver has to be there by law. There are plenty, let's say, of obstacles. And another, not obstacle, another thing that we have discussed with many colleagues is how much impact, let's say, these demonstrations can do in a region so that the general public can see, let's say, the potentials of the CCAM solutions. Having a small vehicle, experimenting for a few weeks and transferring a few people probably is not enough for the general public to get acquired, let's say, the full potentials of the solutions. Of course, projects like High Drive, all the large projects that LOHA is leading, probably can have this kind of impact, but still, it's not large enough, in my opinion.
Thank you. It actually goes to my second question. What role does public perception trust play in the pace of technological development in this CCAM sector? And you said that small scale demos will of course attract people, but it's not the thing that we should rely on in the first place.
Yeah,
right?
I can extend on that.
Please.
Vasilis here, I'm totally on the same page. You see a lot of individual trials showing the benefits of what a single use case could do for a single user. Scaling that would mean that every location in Europe should support that for every user, but that's not a really scalability path. I'm a firm believer of going the fleet direction. Mm-hmm. Whereas if you would have a fleet, a delivery fleet, maybe long haul shipping, that has these automated functions, you immediately see a benefit in travel time, so delivery time. You see a benefit in a reduction of petrol usage, energy usage, and that's on a company scale, and that's a different ballgame. So then immediately a company would be able to have the benefits of these use cases within a certain geographical area. And that then it's different, because then you have a scaling path.
Mm-hmm. Meanwhile, there is a message in the chat. I mean, we can also ask the people to just join in if there's any point that you would like to raise. And Cormac was saying that's why I mentioned Li-Fi earlier. I believe Tesla may be using Li-Fi in the boring company tunnels in Las Vegas.
Yeah, but
I'm not so sure about that, but yeah, maybe that's
the Li-Fi is an interesting approach, because you can just flicker your headlights and any camera can pick that up if it has a high enough sample rate. Mm-hmm. Vice versa, you can do the same with radar. You can complement your radar signal with any information if you would, but that would mean another competing technology for V2V and V2X, whereas we already are in limbo.
Law?
Wi-Fi P versus.
Oh, sorry, Juan, we missed you. I can't hear you for some reasons. Maybe against on my side.
Did anyone else hear me or not?
No, Quinn, I heard you probably. You had a small interruption, I guess.
Then it's on my side. Sorry.
Enter the matrix.
I'm the bottleneck. Sorry. All right. Then Loha was the first raising the hand. Sorry.
Yeah, I was just, I completely agree actually with Vasilis. We also we are part of the Podium project and also another project on CCAM Modi, which has actually cross-border use cases. I mean, definitely like regulation and having like different restriction coming from different governments. I mean, we have like European regulation, but also we have national regulation that also determines whether these use cases are possible or not. It can be an hurdle, but also going back to what Cohen mentioned about fleet and the use cases, although there are lots of benefits of autonomous vehicles when it comes to logistics, still something we learned from award is that for autonomous vehicles to have a proper value proposition for companies, like big companies such as DFDS or others, the whole process needs to be automated because we found out that, for example, most of these companies, something that they're actually really looking for is the shortage of labor right now in industry. And then although we can actually replace the driver with autonomous vehicle, still there are lots of processes that you need actually someone to deal with those processes, such as, for example, when the vehicle needs to be charged, someone needs to put the charger, or for example, when the truck needs to be hooked or unhooked, there is a need for someone actually to handle these processes. That is still actually in a world we realize that if the whole process is not automated, still we actually need someone to deal. And autonomous vehicles, though actually they will deliver benefits, but still the value proposition of autonomous vehicles are not that much to convince big companies to actually completely use them. So probably we have to, apart from the vehicle just automated, we also have to work on other processes and automate also those processes so that autonomous vehicles as part of that process actually kind of enables the whole automation of logistics. That's more related to fleet, though actually for passengers, it's completely another scenario. And probably entities that have been involved more in research projects related to passenger. I think Vasilis mentioned iDrive, more related to passenger. We know Show project, actually Show is also on passengers. They have their own challenges. But for fleet or for logistic, I would say still also we have a long way to go. And there are lots of hurdles that needs to be actually solved before mass adoption and scalability.
Good comment. Thank you. Jan and Eric, you're raising the hand.
Yeah, well, I don't really want to go into opposing a previous comment on Li-Fi, for instance, but it's only a tool to achieve a goal. We have to remember what we want to do with the different things. So CCAM has maybe different goals also and different obstacles depending on what parts of CCAM. I mean, it stands for cooperative, connected, and automated, and it may not. The cooperative part may have different challenges than for instance the automated and Li-Fi or any other sensors or maybe as a tool to achieve those goals. One of the, based in previous experience in different automotive applications, safety where I come from, has been testing standards. If we don't know what we have to accomplish and how to measure success, it's very difficult for different competitors and different actors to come forward and reach something, and you don't even know how to deploy it. It can be, for instance, just testing, but you also have the AI Act, where it's probably be classified as a high risk application, which means that there is going to be some regulatory oversight. And the regulatory oversight is going to be according to a certain criteria, a certain standard, a certain criteria. And the same thing is for what has driven implementation in the automotive world has been consumer ratings like Euro NCAP. But they have it in their roadmap, but they also are awaiting basically how do we test these type of systems? What is the criteria to verify? I mean, how would you give a 5-star to a CCAM vehicle when we don't really know what the 5-star would mean, and where do you put the threshold? Is it just to have it? That has been their approach in the early ones. It's like, okay, they give credit if you just have it, but soon there will be some kind of performance criteria, and if you don't know what the performance criteria will be, it's going to be very difficult to get progress, and that involves consumer ratings. It involves the AI Act, as far as I can see. It involves also other types of things. How do a car OEM know that it's sufficiently safe to launch? Of course, Tesla doesn't seem to be concerned, but most other ones are concerned whether they are safe enough to deploy on a public road.
Very valuable comment. Thank you, Bill.
Yes, to extend or let's say further on what Jan-Erik mentioned, what we are, for example, partially also facing in events is actually treating it also as one entity, the CCAM, but also, as Jan-Erik said, to see also the individual parts of CCAM, so they connected the cooperative. We work, for example, a lot on cooperative and the autonomous parts. So that's something that we are also facing, and then also relates to how we evaluate. So what also Jan-Erik told about what is, let's say, 5 stars. I wouldn't phrase it like that, but it's similar. So what are we evaluating against? And are we evaluating against, let's say, an average driver, against a professional driver? Are we evaluating against, I don't know, a ground truth from a simulation? So, and that needs to somehow also be, let's say, connected to the regulations, and this needs to be clear on the regulation part. And then just to finalize, based on the last comment from Cormac, which says not having affordable tools may be a barrier to mass adoption. I believe that's our case, for example, when we are testing LiDARs, and LiDARs are very expensive, especially good LiDARs are worth actually a car on their own. So let's say outside of research, outside the research sphere, it is a huge barrier to actually have LiDARs in
Yeah,
vehicles.
Please.
May I come in? So first of all, I wanted to thank you to ROADVIEW for organizing the event, because it's so good to have different projects exchanging. And this is as well the reason why we have now CCAM partnership, to connect the dots, to connect the projects, and to try to have a bigger picture of everything. So this is very useful, and thank you for participating today. Someone mentioned at one point how much impact do we have with small projects, and here the partnership comes into the game, I would say, because whatever your, let's say, small projects deliver, we are hoping that it will feed back into the partnership and into the next project. So you could have potentially quite a big impact in the future. So maybe some task for you to think how some results of your projects could feed into the next upcoming calls of CCAM partnership. And I also wanted to refer to the validation that was touched upon, how to rate, how to evaluate. On this, we also have quite big projects actually running in CCAM partnership. They are not here in the room with us today, but they are in parallel looking into this, how to evaluate, and even the new thing will be how to evaluate throughout the life cycle of the vehicle, because once it will be launched and maybe type approved, it will still get updates of the software, and that could totally change how vehicle behaves. So how to keep track of those updates and what happens with the vehicle after. This will be really interesting. I wanted to ask, maybe any of you has done already feasibility studies. You just mentioned the LiDAR as being quite expensive. I was wondering if this is part of your projects, because indeed you sometimes test so many different sensors in one vehicle. Is that really applicable then in real life, or do we have to scale down the sensors, or can we remove some, or do you look into this, how this can later be put in real life actually?
I can jump in here because this is exactly one of the things what we are doing in ROADVIEW. So cost-effective minimal sensor setup. So we have a sensoring where you have 2-3 different types of LiDARs and multiple cameras, let's say 6 different cameras, and likewise many different radar devices. So now the question is, are they redundant? Of course, there is a redundancy, but now the million-dollar question is, how can we detect this redundancy in this sensoring? Can the vehicle relate the redundancy in the sensoring with the perception algorithms, saying, let's say, if it is rainy, maybe do not use camera, just you focus on radar and LiDAR, it is fine, because camera will be anyhow most likely whitish. Or when it comes to rainy, focus on radar. When it is fog, do not trust on LiDAR, because LiDAR is going to give you nonsense on the fog, heavy fog conditions. So those are the things that we are trying to address, and there is a specific task and corresponding deliverables touching exactly this point. So far, we have delivered only one deliverable. The good thing here is that, again, I will recall the fact that in ROADVIEW, we have 4 or 5 different vehicles. It's a good opportunity for us to measure this impact of this minimal sensor setup. So some vehicles maybe need more sensors because of their large scale embodiment. So because trucks are very big, you can't survive with one single camera. You have to always see the back. Maybe it doesn't apply to passenger vehicles. So you can also relate this thing to different vehicles for different use cases. Just a quick answer to your question. I was actually interrupting Jan Erik. You're raising the hand, Jan.
Well, I think it's related to Marcena's comments here also, but I think I can add directly to your comment also there. But first of all, the number of in a project like this thing, the cost in a vehicle like this thing, if the cost is and the time is to collect all the data and do the evaluation. So the delta cost of throwing in another sensor that may or may not be used in the final is small, but that allows you to compare. You cannot add to your sensor set afterwards another sensor if you figure out, oh, I should have used another type of, say, an FMCV instead of just a normal time of flight LiDAR. Would it have made a difference? I can't add it afterwards, but if I throw it in from the beginning, it's a very marginal cost. Doesn't necessarily mean that I would need them in a serial implementation. Mm-hmm. And I think that's probably a part of lacking, that many projects don't really give a comprehensive evaluation how the different sensors performed in this type of criteria. But I think that there is so you need to evaluate them, and that means that it's not just whether I need LiDAR or radar or whatever. But again, if you want to evaluate, as you said, I can in fog I can use just radar. Well, it depends on what you're going to see. Again, it comes back to the criteria. If you're going to use some of these products, show the road obstacle things, that 12 centimeter road object. Well, it's very difficult to see them with a sensor that doesn't have the resolution to distinguish whether an object is 12 or 15 centimeters, whether it's drivable, overdrivable or not. So you have to have, it again depends on what goals do we need to achieve. So when you say that and you conclude a certain sensor, it depends on how you compare. And one of the problems in many products is that they compare it to different measurement sticks for different application areas, and that means that it's very difficult to compare one project results from another one. And that brings me to the final project, and I'm also involved in, I'm chair of the mobility group in Photonics 2021, which is another PPP like CCAM, where we define projects, we define SRIAs, we write the calls, but then it's up to the commission, and we basically don't have feedback. And the same thing is with CCAM. You can control the calls, but you can't control the output and make a feedback into following projects. And I think that's on a higher level even for the commission to see how can we benefit from different projects for follow-up projects that they actually utilize previous results in the most efficient way. But that's a very big and very challenging topic, and it's been a lot of discussions I've been involved in, but it's another one. So that maybe I addressed three different things, but it was Marcena's and you Aaron's comments there. So.
Yeah, thank you. Meanwhile, I'm trying to read the chat because there are some questions as well. So one of them is from Charu Sharma. He related question to the current discussion. He says, so how critical are automotive grade cameras within the overall sensing system for autonomous vehicles, especially in comparison to other key components like radar, LiDAR, and AI? Is there any hierarchy or ranking in terms of the importance of these technologies when it comes to the sensor fusion and ensuring safety and accuracy in autonomous vehicle performance? To my best knowledge, I'm not aware of any study like that, but I know that there are studies showing like how to locate those sensors in the vehicles. So what is the best position when it comes to having one specific LiDAR at specific resolution? But no one can say like, use this instead of that sensor because it's highly task dependent, right? So you may need specific sensors only for one specific task, but when it comes to another use case, maybe it is redundant. So it's more task oriented, the selection. maybe Jan-Erik has a comment on that?
Well, again, maybe I'm too academic, but it depends on what you mean by automotive grade. But given that we are a big tier one and producing so-called automotive grade sensors, I think that I have at least some insight. It again depends on what you want to do, because if you mean automotive grade, that it should have the what do you mean by that? I mean, does it mean that it should be waterproof and dustproof and IP class, or does it mean that there has been other things like that? But for a product like this thing, if you're going to have develop automotive grade sensors, it's not. Will take the whole product. You won't be able to do any other things like that. So again, it depends on what you want to do. Most of these type of products is proof of concept, and there you have to have a relevant sensor and then take precautions to make sure that you can use it in a test vehicle and it doesn't have water ingress, etc. like that.
No, I fully agree. But I think the question is saying, like, what if I have an automotive grade sensor ring? Is there any way to compare, or is there a hierarchy which says, like, use this specific instead of the others when it comes to these conditions? I don't think that there is any study like that, at least to my best knowledge. But we are working along these lines to address this. If you are looking for something along these lines, maybe you can search for adaptive sensor fusion. Those are the keywords that people are using to adapt to the situation by giving some weights to specific sensors before the fusion.
My advice there would be to follow basically a scientific paper. Basically, you have to describe your introduction and also a method, and describe why your method is relevant to what you want to do. Yeah. And I think it's the same thing here. We can't do more.
Fine.
To follow up a bit, car manufacturers tend to have their own preference on what type of sensors they want to do. One of the key things for car manufacturers is costs. So more costs, more sensors mean more costs. So they will choose a certain one with which they have agreements with their supply chain, and they have knowledge of, and they will build upon that. So is there a particular order? It could be. AI is not a sensor. It's a different technology component. I doubt it's a key component, actually. But yeah, that's how it currently works. And you see that indeed additional sensors are put on top to see what works, what doesn't work. And in the end, it will flow in towards the automotive grade cameras that are not for your car.
Let's take the last comments on this, because I would like to jump to another very important question, because we are already half an hour done, halfway done with this part. So let me see who raised the hand first. Jan-Erik, again, you, and then we go with Bill.
Just be very brief on cost. Cost is very much a scaling issue. You can't extrapolate that. So what it will cost in high volume is very difficult to predict at the onset. So that is a separate topic. So if you're going to select things for what is affordable for zero volume now, it will change a lot of things in the past. I know for instance, many years ago, I was the introduction of thermal imaging in Europe, and I considered crazy that I put the sensor that cost more than the car I put it on. But I made a cost estimate and said that it will not be that, and that was sufficient to convince them. So but not all of them will follow that thing, and they will say, "Oh, it costs more than $50 now, so I can't do it." But it depends on when and where.
Vasilis?
Yes, just want to add on to what Cohen mentioned before. I mean, yeah, what is more important, if it's leader is more important than other, I'm also not aware, honestly, but both in Invents and Podium, we are investigating how, let's say, to reduce, if possible, the number of potential sensors, if possible. I mean, if you have, let's say, collective perceptions, probably you can use the sensors of a nearby vehicle. I mean, and this limits a little bit, but probably the need of some sensors. But not sure yet if can eliminate those kind of sensors. Also in Podium, we are trying to check if the road infrastructure, like having cameras or readers on the infrastructure, can support the decisions from the vehicle, so that you don't need, let's say, redundancy sensors on the vehicles. And we also investigate actually for the VRU detection if, let's say, simple messages or trajectory prediction of a VRU that can be, let's say, communicated to the autonomous vehicles through the cellular network or any other network is enough, let's say, to enable this kind of VRU prediction, VRU position prediction instead of using, let's say, cameras on the vehicles or on the infrastructure.
Thank you. So collective perception is already addressing this redundancy issue then. So let me have a follow-up question, which is also aligned with all this AI and also this sensor setup that we have, or you have in your projects. So based on your current achievements, what are the next technical software and hardware issues that you may list here? So you can also refer to the role of AI involved in your innovation. So is it mainly AI-driven? People also call data-driven approaches, where you put all this data in big black boxes and then you try to solve. Or how much AI is involved in your innovations? If it is that much, is heavily relying on AI, then how can we solve standardization or regularization-related issues when it comes to deployment? And is there anyone who can comment on this?
Yeah, I can.
Yeah, please.
Just for putting people on the ground, AI has been there for decades. It's being used in vision detection, object detection. This has been there for a very long time. The new thing with AI is generative AI. And that's what triggered a lot of people that, okay, it's dangerous, we need to think about it. And actually within the Traffic Management 2.0 platform, we wrote a very interesting white paper on how to classify AI within transportation, because what the AI Act basically says, everything AI related to transportation is high risk, so you need to be very careful and you cannot do anything, which basically makes it impossible for all of us to do any AI within transportation. So we effectively neutralized that with a white paper that actually last week got the award for the, it was presented in a session, and that session got the award of the best run session of the ITS World Conference. It might be interesting to have a look at that. Basically, it gives a classification of what is your AI doing according to 2 axes. That makes it easier to justify that you can implement it within trials and within products. So I'll paste the link in the chat shortly afterwards.
That's really great. Yeah. Anyone else? And how are you using then generative AI? So yeah, generative AI is the new trend. I fully agree. But AI was also used in the object detection, sensor fusion, all downstream perception tasks heavily. And but are we using generative AI only for generating new training data, or what are the strategies that you use? Maybe a follow-up question on that. We continue with Jan, and then.
Well, the question is whether AI or sensors and things like that, can you really separate them? I mean, it's not an issue whether I can have a LiDAR or a radar or whatever, because they will have to use some processing, and that processing is most likely machine learning, and it's going to be applied. You cannot get reasonable data, especially if you add adverse weather, add a thing with the obscurance in the atmosphere, and you have any photonic sensor, you're going to get lots of noise, and you're going to get lots of other things that you need to deal with in a clever way. And machine learning is the tool to go. So you basically can't have the sensor operate reasonably without the machine learning, and machine learning without the proper sensor doesn't make sense either. I mean, if you have a lousy sensor, it doesn't help with the best machine learning. So they need to work in unison, not as 2 separate issues.
So sensors and AI are intertwined, so we can't decouple them. We should treat them in a way that they are complementary.
Exactly.
Agree and disagree, but I know that there are still companies relying on non-AI solutions as well. For instance, take LiDAR and do really statistical things on top and show that it works. But I'm not so sure how successful they are, but there are companies, at least SMEs, doing that one as well. So, Cohen?
I think if you can use deterministic solutions, they are better because it's easier to test, but it's very difficult in a complex environment to use fully deterministic solutions.
Scalability, exactly. Scalability is the keyword here.
And easier to prove why they work, which is also very relevant. AI is really good in finding patterns where in huge numbers of data. And one of the, by the way, I can't paste the link in the chat to the AI paper because it has been
disabled. Mario, could you please help us just take a look at that issue meanwhile? Or pass it to Mario, he can paste it there.
Yeah, I think either way.
Just type tests here. It works.
Any AI system is as good as the training set. And the ability to find coherence or find a pattern. But one of the things that we are investigating actually now within the traffic management part is, can we create automatic response plans? That would be a very good one because traffic is stochastic. You know very likely that there will be traffic jam at a certain place at a certain time. You don't know how long it will, what specific time, if it's different when it rains, etc. So the variety in factors affecting that specific traffic jam are enormous. And the problem is it's not something you can trial. So if you have a solution and you apply it within the field, you cannot deduct what happened if you didn't do it. So you're a bit stuck there in traffic management, and that automatically opens up a lot of opportunities for generative AI. So, okay, given the traffic situation, what we know from all the other factors that are affecting it, what would be the best response plan currently? But that's under investigation currently, if those kind of things are possible.
Mm-hmm. I can also add a follow-up comment on the question that I asked, because we are now talking about how much AI is involved and what are the technological issues that we have here. So we have different platforms, vehicle platforms, running in different regions in Europe. And each vehicle is actually using maybe the same sensor with a different resolution. Let's say both have same number of sensors, LiDARs and camera, but they have different resolutions. You have to go from LiDAR 128 to LiDAR 32, let's say. In that case, having AI is good, but it also introduces another problem, which is the domain shift, right? So now you have to run another test, another trial in the new domain to collect data with this lower resolution of camera. So whatever you have trained with LiDAR 128 will not be functioning just with the same performance when you switch to LiDAR 32 vehicle. So even if you are using the very same brand, right? So it is something that is now staying like a problem and a challenge on our table. I don't know whether you face this kind of things. Of course, it's a well-known problem, domain shift. But normally when we say domain shift, just when you go from, let's say, California to Sweden, yeah, there is a domain shift. Or when you go from one camera brand to another, there is a domain shift. But even if you are staying in the same city with the same vehicle, but just changing the resolution of the sensor, this may even introduce an unknown problem or extra workload on your shoulder. Good. Any other comment on this?
If not, I would. Yeah,
there was
one.
Yeah, I have a comment similar to what it is important to be solved in the future. I think these enormous amounts of data, I think it would struggle the network, it could struggle anything. I mean, no matter how AI can evolve, having numerous of sensors recording data and trying to, let's say, transmit it to the edge or to the cloud in order to perform any kind of operation, I think it will bottleneck any kind of future, let's say, infrastructure, no matter how fast it can evolve. Which I think it has to be taken into consideration. And on top of this, the privacy coming out of this, because you have hundreds of cameras taking pictures of you, of your kids, of your whatever, that it's always useless information for the traffic management, but still needs to be considered before being used for any potential use. I think this is something that needs to be taken into consideration, I guess.
Fully agree. We faced the very same privacy problem after logging with the camera. So we spent really months on blurring. Of course, there are some automated tools for that, but you still have to prove it if you want to release your data public.
Yeah, I've heard that
a stream of video that you need, let's say, to make any perception or whatever, needs to be cleaned up of, let's say, privacy potential things, but also to be reduced in size, because you still have in a junction, you might have the same feed coming from 10 different vehicles, which is still useless. I mean, for the edge computer to perform any potential computation. Yes,
I agree.
Yeah, I just wanted to make a little remark that indeed with the huge amount of data, we have to be slightly more careful, maybe to, a bit what Jan-Erik said. Why did we even start with working on CCAM? It was, among others, to make the road transport more sustainable. And now if we start having so much computing power on board and in the cloud and so on, will it really be sustainable? That's another question. But I wanted to go back to your presentation from Podium. You mentioned trustworthy exchange of data with the cloud. And that was interesting for me, because I understand they are not exactly clear ways yet between OEMs and infrastructure of how to exchange the data. Would you have good solutions then? Would you have something to propose already as a solution that could be acceptable for OEMs?
Not in the exact problem you mentioned. The problem that we are trying to face in Podium is this the software integrity and the data truthfulness of the data that is used by the vehicles and the infrastructure. So we're using something that's called Trust Platform Module and attestation reports to make sure every time that the pieces of firmware or hardware, the data that they are sent are, let's say, what is supposed to send. So you might have sensors that reads, let's say, the speed and is performing well, but at some point something happens and malfunctions. So we need it at any point to have this kind of truthfulness of the data. It's not what you mean. The question is how to exchange data between, let's say, the different entities in a more straightforward way, I guess. So it's not the same thing that we're trying to.
But it's to prove the quality of data, then.
To prove the quality, and that the sensor that is supposed to read something is reading all the correct metric somehow. Not out of malfunctions, but not out of behaviors misbehaving.
And Bill, for events, you mentioned collective perception, also including infrastructure sensors, right? It's another full topic.
Some RSUs, yes. Some roadside units, yes.
And do you also look at feasibility of implementing those? Because I also hear a lot from road authorities who say we don't have money to put roadside units on our roads. We have to maintain the asphalt and bridges. So how
not in a hardware level, but in simulations. So it's the RSUs. We use it as smart RSUs inside Carla. So within a simulation environment, not the physical hardware in a road.
Yeah, so that would be another question. Is it really feasible to have that in real life again?
We have it in the ROADVIEW project. So we have a real infrastructure. We have real sensors. We record data from the real environment under snowy conditions. So we have one setup in Finland, and it is already communicating with the autonomous vehicle from VTT. And we have a video. Maybe after that we will show it in the video session. From the sensors on the infrastructure, we send a signal to the vehicle so that it can go to a safe position. But we are not working with road authorities here. because more, it's not a controlled environment. It's an open road to public, but it's not a collaboration with any road authorities. But what I know from Sweden is that they are very proactive. They are willing to have this kind of innovative solutions because they want to really reduce the number of accidents with this kind of technologies. So yeah.
For into CCAM, we have several living labs in which it is rolled out. Actually, that's the whole purpose of these living labs, to have it available. So Trikala, for example, or Vigo, or even Tampere, they all have a lot of CLOSA RSUs lying around is the wrong word. They're hooked up to the actual systems in the city, so you can use it there. Rolled out.
From my side, I mean, yes, coming back to the collective perception, the idea is not that it is mandatory from the road authorities to have, let's say, infrastructures and cameras and leaders, but you try to take, let's say, to use as many potential sources of information as possible in order to make some better, let's say, computations and a better perception. If it happens to have, let's say, a roadside unit that has better view of the junction, or you have other vehicles coming from the different direction, then this kind of information is good to be involved in this collective perception scheme. Otherwise, the vehicle is still the one that has to take the decision based on its own, let's say, ODD. It's not mandatory to have, but it will be great if the infrastructure can also be involved in the overall process.
And actually, it should, because there are quite some places where you just can't see around the corner.
Exactly, yes.
We have a nice example in our shared project 5G Mobix facilities where the Spanish bridge, if there was a shuttle going through a bridge, which basically is a cage of Faraday metal on the sides, and at the end there was a pedestrian crossing. So there's no way you're going to see that pedestrian as an automated vehicle unless you receive it from the infrastructure. And there are a lot of these corners within the small scale, narrow streets in all the old towns available in Europe. So you can't do without infrastructure.
Pretty much all the urban junctions.
Yeah, indeed.
It's very difficult
in close quarters in all cities. No way you can do that without. Indeed.
Christian?
Yeah, maybe something to add on this, because we are also in close contact with CEDAR. So they struggle basically with the technology, because they don't know in which technology should they invest their money, if there is some money left. So not there are some very first countries who want to invest some money in digital, but actually they see the risk that they invest in the wrong technology, because no one can look into the future, what happens in 5 to 10 years, and then you have spent maybe millions of euros in the wrong technology. And just to add this, I saw, but please add on this. There are 2 studies from the European Commission that are somewhat contradicting between 5G and G5, and I think this is a real obstacle, that there's no clear view about the appropriate technology for the investors in the public infrastructure.
Yeah, and I think it is also true with CITS, for example, like countries that have already invested a lot and heavily, for example, on CITS, they're pushing towards the use of CITS even for CCAM application. But then there are lots of other countries which have not had the opportunity of actually like huge public funding, such as, for example, Austria, Germany, who were like some of the first, first movers, and they got lots of public funding actually to implement CITS. But then when we come to countries such as Spain, Italy, we're like, or maybe many more countries where the investment was not that much actually there at the beginning. And now those countries have to invest by themselves, like on CITS. Then the question is actually who's going to pay? And of course, I agree with Christian. And then is it actually the right technology that we have to invest? It's so expensive. Is it the right technology that we have to invest in? What if actually in 2 years, then there is another breakthrough technology and then CITS gets obsolete? That's also a big question that I mean, when we talk about infrastructure as an infrastructure owner, then we have to actually answer to those questions. And sometimes, since they're already going late in comparison, for example, to the others manufacturers, then the question is actually, yeah, what is the right technology that we have to invest in with the limited resources we have?
The funny thing from an infrastructure point of view is that the replacement rate of equipment on street is like 5 years. So if you made the wrong decision, it's only for 5 years. And within 5 years, you will not have a completely new technology. There's a G every decade, so you can very clearly predict when you will have 6G or 7G. You can write that now, so you know if you've made the wrong investment decision. And if you did, then yeah, it's only 5 years before you need to replace your equipment again. So, but that also means that driver by investing it.
Or even the fact that actually others manufacturers are already investing a lot on technologies to be independent of the infrastructure. So one of the main, I would say, like issues nowadays with the companies is, can I be independent so that I don't depend on the infrastructure provided by the governments or by other companies?
Yeah, but what they're going to do? Going to fly? Because then you're also based using,
even if you fly, actually, you need infrastructure to fly.
You're always using infrastructure, so you cannot be independent of that. It's clearly impossible. Even the signs you need to see. You need to know the traffic lights. You need to know where the maybe congestion signage is or any rerouting of traffic. It's all infrastructure based, so you cannot do it without infrastructure. And actually, the ones that do, Waymo, for example, they're messing up really bad. They reroute their traffic completely the wrong direction. There's a nice assessment of Uber that assessed the navigation apps, the 3 main major navigation apps. So Google, it was Apple, and it was Waze, and Waze was by far the worst. They're like 17 minutes delay with respect to the others for trips, so, because they reroute traffic to all the wrong places. So you really need to be in contact with infrastructure, because in the end they dictate what you're allowed to do.
Well, just to add here that I guess it's not about black or white, but maybe lowering, let's say, the dependence on infrastructure. For example, in events, we do a lot of CPM V2V, CPM,
Yeah,
not V2I.
It should be more the how can we reinforce each other? That should be the case. So what can you do from a car perspective, vehicle perspective, or traveler perspective? To reinforce the management part, and what can you do from the management part to reinforce the traveler part? And then you're moving into the term that's called orchestration more and more. But that's a cooperation between all the stakeholders within the ecosystem. But that's a whole different discussion than this.
That's true.
Jan Erik?
Just a small remark. I mean, I agree with our friend here from Ertico, basically, but I think that there is something that low-hanging fruit for the infrastructure providers is to consider the automation systems in the vehicles when they do. If they, for instance, have a clever idea of how to improve the road lines for constructions and invent a completely new road line structure, it may not be detectable by the current vehicle fleets because they haven't been trained on that one. So that may cause some havoc. It may not actually cause safety in case they have a automatic lane keeping on and then suddenly enter into a construction zones where suddenly it doesn't work. So it may actually be so. And I'm not always sure that they always consider non-human readers of what's being put up on the roads, but I think that's just a small detail. But I think both sides can benefit from each other, and considering that we have an environment where it's not just human drivers. Even if the human driver is finally responsible, they at least have support from technology.
Yeah. To complement that, there's ESAT levels are the levels for infrastructure in which the infrastructure states how well if an infrastructure is drivable by an automatic vehicle. Actually, there's a project, EVA Roads, that just started, in which we try to assess safety aspects related to infrastructure to provide these ESAT levels, to make it easier for car manufacturers and vehicles to check if they can drive there safely. Because indeed, yeah, you're totally right. There's cross fertilization necessary there.
Could you paste the name of the project in the chat? Thank you.
You can't paste again, but maybe again you can use the same tool. You can approach Mario.
Okay, but I think we are getting till the end of this session. Maybe just one last question to all of you. If you could share with us, what do you think is the potential of your solution for the whole mobility sector or logistics, or maybe some specific use cases? Where do you see the biggest potential? Maybe we can make a round. Eren, would you like to start?
Yeah, I'm thinking about that. So because we are proposing different innovations, I think the one of the most important one is like once you so what we claim is that we are gonna increase the robustness of our perception. So whatever sensor we use, we are gonna use our pipeline, which will first filter out the noise in the sensor coming from the rain or snow and so on. Then we will call the downstream task, which is supposed to be running even with higher accuracy. So in the short term, I think we are approaching to that goal, and we have already strong scientific evidences supporting our hypothesis. So robustness in the perception, I think this is one of the innovations coming with our project.
Great,
Anyone
thank
else willing to add?
Share.
I can go next. I mean, for us, because the major part, okay, now I mean the use of the edge computing, it sounds mainstream. It was not the case back in 2021, but so I cannot claim this as the major potential of the project. But I can sure mention, I mean, the different use of different connectivity options, this multi-connectivity, and the use of any potential different available networking capabilities of the infrastructure is something that is worth investigating. It is something that can, let's say, enhance the already infrastructure, the already deployed infrastructure, without at least, let's say, delaying the needs of new deployments.
Thank you. Anyone has something to add?
The key points from InterCCAM, the key benefits will be basically a scale-up of CCAM to allow it to drive in certain areas because it's integrated with the traffic management technologies. That would be the main output, the main benefit.
And yeah, from events, I think it's in the general sense it's quite close with ROADVIEw. So let's say the heavy weight is on the perception and on more robust perception through collective perception that we worked a lot, and through also the real-time self-assessment.
Jan-Erik, I think you are the next up, maybe. For the AIC, it's already over, right? So you have just a couple of months left.
I'm not really sure I have any better things to add. So
I think the gating vision that you guys are using and proposing as a solution, I think this could be one of the things that we can talk about.
It comes down again to what I started with. What do we want to achieve? If you take this use case of drivable objects according to the new ECE 157 regulation, you need resolution. If you're going to see an object at 150 meters that's 12 centimeters tall, as the example here, it means that you need to have roughly 1/100th of a degree, if I calculate it correctly in my head here. And that's very, very high resolution. There is no LiDAR even on the drawing board that can give that type of resolution. So it's comparable to being on the soccer field or football field, as we say, on this part of the pond, and you're on one goal line and you want to see a football on the other goal line, and you should be able to judge whether it's a junior football or a senior football. That's pretty tough, and you need to have a sensor to match that. And so far, the focal plane array is probably the only one that can get to 5, 6, 7 megapixel resolution for a reasonable field of view. And gated imaging is, of course, using a focal plane array. So that's one of the things. But it again depends on what do we want to do, what do we want to see. If the goal is the new FMV SS127 to see pedestrian running at 75 kilometers per hour, it's a different story. You can have other types of resolutions and different things. So again, what is the goal and what is the things that we want to achieve? Gated imaging, everything has pros and cons, but it provides an opportunity to have high resolution, but it brings it with other issues. The overdrivable use case is important because you basically, it's not a classifier, but it's a measurement stick. You need to measure the height of an object sticking up of the ground. And that means if you have, say, a boxes or a roads pallet or a piece of wood that was shown in one of the examples, you can't really tell whether it's a small branch, a small piece of wood close to you or in a 2D projection, or whether it's a big trunk far away. So you need to have some depth perception, but it doesn't necessarily mean that you need to have centimeter perception, depth perception, depth accuracy, like you can get from the best lidars and so forth. And the same comes to radar. Radar is an excellent tool, especially in adverse weather, but it's very difficult to get the type of resolution that you want, but it can probably augment other sensors to help you in the different things. So, so again, it maybe I sound too academic here, but I mean, it depends on what is the problem at hand and what do we actually want to solve before we actually get into deciding exactly what type of solution. And when we want to compare different, I mean, the sensor is only a tool to achieve a means. But we have to ensure that it actually is part of that, and we have to look at the whole system. But maybe it's not a simple answer that we want to have, but life is usually not simple. That's why we need lots of engineers to solve them. Otherwise,
and lots of funding we need to solve them. Very good. Any last remarks, because we are like at the end of this session? If not, I would like to thank the speakers again one more time, the panelists. I really appreciate that. It was fun to go through those challenging questions and hear your views on that. Appreciate that. Now, the next item in our agenda is this video demonstrations. I don't know how to proceed. Mario, we don't have a breakout room, so how should we proceed? Each panelist should share the screen, or?
Yeah, I think we can go in alphabetical order. So we can start with AIC, then awards, events in CCAM, and they can just share the screen and just explain a little bit the results that they're sharing in videos.
Okay.
So the first one would be AIC.
So Jan-Erik, if there are any videos that you would like to share with people.
Let's see if I can be friends with Microsoft again. That is not always the case. So if Microsoft is kind to me, you should see an orange screen now.
Yes, we see an orange screen.
This is just an example of some winter testing. It shows some about the complexity, and one of the issues, this was in cooperation with VTT, and I'm called Magna now, but we were acquired by Magna a year ago. And the different, I've shown that in the past, but this is basic. And one of the challenges here is that we were actually collecting in heavy snowstorm, but it's very difficult to record videos in this heavy snowstorm, especially when we had drones up, because it's not possible to fly them there. So we are actually then taking it after the snowing stopped And then, of course, you don't have as challenging situations. So we were driving then more on the side of the road where you still have some snow. But again, when you talk about snow, this is northern Finland. You can have dry, powdery snow here. It wasn't that cold, but it still was with low humidity, and you get a fluffy snow. But again, most of the snow had been cleared from the road. I mean, the thing with the winter condition, road authorities in winter conditions, they are used to snow, so they have the plows ready and collect. But this is what we did. We actually also had the standardized contrast targets according to the SAE's recommended practice, so we could measure the contrast here we don't have as much snow flurries as we would like to have, but that's basically becomes on ability to record. And here we see some conditions of different how different sensors from visible sensors, polarization, day and night, and also in one of them here on the left middle, we have some interferences because of different sensors, active sensors, and then they are not synchronized. You also have running against the sun, which is another sun glare is another issue. But it at least allowed us to make quantitative comparisons between different conditions. I mean, otherwise, how do you assess what it was? What's lacking here is that we didn't have good tools to measure the snow content. If you look at SAE recommended practice, there's two means of assessing that. One is to basically measure the size and the count of particles, and the other one is the effect on visibility. But it's very difficult in a driving dynamic situation to measure the particles and I mean, in this case, the snow flurries size and amount, and it's also a very dynamic process. So it depends on how close you were and what type of rear end the vehicle here. We used here, as you saw, a van which had a very vertical side, which is helps us getting more aerodynamic suction to get more flurries up than if you would have a sleek, say if I would have a Porsche 911, it would have been much less than if I had a Volkswagen Transporter here. But yeah, I'm not really sure it tells the whole story, but it shows some about the complexity of doing this type of test. But if I had done the test in the south or Sweden, where you would have much more water content, you would have more slush and more that the sensors get blocked rather than here. You can get sensor blockage even here, but that's more that it was a high amount of snow. If you go into rain, it's a different story and so forth. It depends on how smooth the road is and how much is the water depths. We have done tests to show that the speed is important, but the water depth is important. And if you have a worn road where you have a lot of truck traffic, there is basically cavities in the road where most of the trucks are moving, where you collect a lot more water. If you do the test on a test track, which usually has a very controlled surface, and even for where you do aquaplaning test, it's very difficult to get 9-10 millimeters of water depth level on the controlled test track, because they don't collect that much rain. Then you have to basically put some wall in and things like that. But if you go on a worn road and drive on that one, it's not unreasonable to get up 10 millimeters of water level. And the spray amount that you get at 10 millimeter is very different from if it is at 2 millimeter.
Mm-hmm. Thank you. If there is no other video that you would like to share,
no, I think this is good enough.
Yeah, very impressive. We can continue with award project if you have any videos to share, Law.
Yes, let me see if I can share my screen and if you can hear. the video. Can you see the video?
It is coming, yeah. If you make it full screen, it will be nicer.
Yeah, this is the video of hub-to-hub case, which I talked about as our first use case. So here, actually, the truck comes from the Divishenker logistic warehouse. And as you saw, it actually crosses the public road. And it gets to the other warehouse they have and provided by Rotax. In all the pilots we implemented, actually, there is a safety driver on board it, but in most cases, safety driver is not doing anything. It's just the vehicle, actually, which is operating. This is where you see that actually the vehicle is synchronized also with the traffic lights. So it understands when the traffic becomes red or green, and when the vehicle is allowed actually to do maneuvers or actually turn right, left. Also, if you can see, we also have sidewalks. Sometimes people were walking in both sides of the road, and also the vehicle was able to detect the pedestrians. And the use of fleet management system, as commented previously by Cohen, also helped us a lot actually to identify which areas, because the fleet management system that we use in Award was provided by Applied Autonomy, and we could have lots of information about the infrastructure, including if there is any area that cannot be accessed by the vehicle, etc., or even the traffic. So that also helped to better implement the pilot demonstration. So it was not used only for getting orders and dispatching, but also to understand better the environment. And then I think we also, here it's not in this video, or we don't have any captures of the teleoperation, but also in this pilot, we did the teleoperation. And the vehicle was controlled by a teleoperator. There we tested actually the impact of network and connection, for example, 5G or 4G, and how actually it might impact the autonomous operation. This one is the use case of forklift use case. This is used, the initial idea was to actually use this vehicle in combination with the track. So this vehicle or the forklift is capable of loading and unloading the vehicle, and then the vehicle is carrying. But at the end, we couldn't demonstrate it because the type of forklift we had was not actually the matching type for the track that we had. The track was much higher, and the forklift couldn't reach the height of the track. So we didn't do the demonstration, the combined demonstration, but the initial idea was to combine so that we have a more automated process. Right now, is still someone needs to actually put the packages, etc., into the car or into the track, and then the track actually goes from X to Y. But in the future, it's expected that automated forklift actually does this process as well, the loading and unloading. And then the track then drives the goods from A to B. Here we are demonstrating how concise the forklift can be when it comes to dispatching different goods. Here, the forklift is trying to identify where the packages, where the pallets are, and then grab them. And then it has to actually then move it to the place where it needs to be delivered. This was done at, as you see, at AIT's place, so it was not real operation, but here you can see actually the idea is that the forklift then loads the track, and there is no human intervention needed. We couldn't do it with the autonomous one. This track is a manual track, but we have demonstrated that it's possible. Then the use case of airport was really important for us because we demonstrated that automation is also possible under harsh weather conditions. And we did it with the Track Easy. This is a short video of the Track Easy and what Track Easy is. So this vehicle is used right now in some airports around Europe. And there is a joint venture by EasyMile and TLD, which is intending to commercialize this autonomous vehicle and provide it to different airports. This case is a little bit easier because it is performed in confined area, though with mixed traffic. Mixed traffic in the sense that there are actually other vehicles around, pedestrians, etc. Let me see. I think here we still don't have actually. This is this site we had in Finland, and as you see, there is a lot of snow. And the idea is to test whether the vehicle is capable of operating. As I think it was Jan that mentioned, it's the problem when it comes to harsh weather condition. It's not that it's just snowing. The main problem is that the road is slippery, and also the vehicle cannot identify if there are obstacles such as stones, etc. But then this demonstration actually shows that with the award sensor stack, it is possible to also operate under harsh weather conditions. I think that's it from my side.
Thank you very much. I really appreciate that. Then Bill, is there any video that you would like to share in events?
Yes. See. Do you can you see the screen?
Yep.
Okay, so the first one, let me pause a bit, is work we are doing on the, let's say, decision-making part, and it's called intention prediction. Now, the video that you will see is from the vehicle, and it tracks the different vehicles. And then here we measure 3 different metrics. On the top is the probability. I will let it play. So on the top is the probability that the vehicle will do a left lane change. The one above is the probability of the vehicle doing a right lane change, and then the one on the bottom, the metric is about the probability of the vehicle keeping the lane, so staying in the lane that it currently are. That's the first part, so it's a 3-part video. That was the first part. Then the second part is some visualizations in Carla on the collective perception messages. And then also, so on the left is a bird's eye view from Carla, and on the right is translating this into a grid. Then we can depict the probabilities that we find for the grid to be occupied. And then the same video from, again, left is Carla, but from the point of view of the different vehicles. And then again on the right is the grid that we can depict the probabilities. And lastly, we'll show you an excerpt from one drive from the ICCS demo vehicle. within the NTUA campus in Athens, and then how it recognizes cars. This is a latest integration. And to add, because it's something that I didn't say in the presentation, because we currently don't have any visuals, we are in the process of integrating. Our intention is to actually run a hybrid experiment using the ICCS demo vehicle, in which the demo vehicle communicates with Carla and vice versa. So vehicle sends, for example, its position, and it's any object that it sees, it can send back to Carla, and also Carla can create virtual objects that it can send back to the vehicle via ROSBAX. So it can be a hybrid experiment in which we can also, for example, simulate weather. So even if we don't have bad weather in Greece, which we rarely have, we can actually have the actual vehicle outside and be able to have Carla feed the vehicle with virtual objects and virtual artificial bad weather, and so on. So these are the three main parts that we are mostly working from the ICCS part. There were also other videos from different partners, but let's say it's sometimes a bit complex to get the permission, and also I wouldn't be able to a large extent to answer more complicated questions in work of other partners, especially very technical work. But yeah. So any questions on what we're doing?
Thank you very much. Maybe one question from my side, like, because you said that you can combine simulator together with real vehicle, that's totally fine. But when it comes to simulation of bad weather like snow, you can simulate snow in Carla, yeah, but sensor readings in Carla, let's say simulation of LiDAR beams, are not reliable. And how are you going to solve?
Yeah, let me be clear, we're not there yet.
Okay. Because those are the problems that we have faced, and we don't want to go with this kind of tracks. So we decided we're going to use real sensors, because you can simulate the sensors, one thing, but when it comes to bad weather, then you have to also model the noise in the weather conditions, right? So like, how do you want to model the noisy raindrops? How do you want to model the snowflakes? So once you model it, then you can simulate them. So it is not that much.
I guess there are there's also the option to have, because we had the specific task focus on not just on data generation, but also on exploring different data sets. For example, a Canadian data set on adverse weather. So I guess it can also either be something complete from the simulator, or it can also be from an already assembled data set. Of course, it differs on the infrastructure, but I think that's something interesting to explore, especially for us on the south, that we don't get any snow.
Yeah, maybe we can talk a bit more because later after this, because we have some solutions for this. Maybe we can have a joint demo or joint collaboration when it comes to sharing data and so on. Yeah, let's keep in mind. Thanks a lot, Bill. And then we continue with into CAM project. Gwen?
Into CCAM, indeed. It's,
into CCAM. Sorry.
Integration and interoperability, so that means the two, and then CCAM. But first, what a marvelous things we're all doing together. It's really nice to see. You should see VTT again, right?
Yeah, I think VTT is the winner of this webinar. We heard their name multiple times.
Yeah,
although they're not there.
No, you'll see some snow in this one as well. This is, as mentioned, we are doing the trials now, and I will have these demonstration events in which we record these videos. It's actually one of the first ones that was done. I have another one from Trikala, but that's actually only testimonials, and that's less interesting to watch. So I'll stick to this one. We'll look at the interaction of trams and shuttles, autonomous shuttles. So what you see, there's a safety driver, which is a mobile app, and it shoots the use case itself should increase tram efficiency. So what you don't want is that this pod automatically jumps in front of the tram. It should wait. So what you'll see here is that on the right you see the pod coming in at the bus stop that's over here on the left, which you see, and there's a trigger arrow for the tram stop over here. Now this one will stop because there's a bus stop anyway. It'll wait a while. In the meantime, you see the tram coming, and it's what you see in the middle is the safety app. Safety driver doesn't do anything; it's just a safety driver, but it can push the stop button. Now, once the tram goes, you see that the tram departs already. That's the shuttle starts as well, so that you see the tram passing in front of us. And after that, the shuttle can take the shared lane there as well, because this lane is only allowed for trams and for this trial. That's the Tampere use case that you see here, and you see this interaction between trams. It's a different modality, and the shuttles actually works really well. Otherwise, the tram should have performed an emergency brake, or the shuttle. In both cases, it's not really convenient for the people inside. It's the only one I have currently of the use cases. More are coming.
Questions?
Questions?
No, I don't think that's the case, but you don't have any more video, right? That you're done.
No, indeed, because we're trialing and we have planned awareness events, and the last one was just executed. So yeah, of course, we don't have a video yet.
Sure. Then it's my turn, ROADVIEW, if I'm not wrong, right? Let me double check. Yes, we are the last one here. I'm going to start sharing my screen. And in the chat, I will simply paste, because I'm going to run those videos from YouTube channel, our YouTube channel. So here we have the YouTube channel. You can click on the link and see all the videos there. So I will start with the first one here. Let me see. Can you see my screen?
Yes.
Yes. Okay, good. So I start here with the data set that we created. This is emulated rain data set. So in Germany, we have a setup where we apply raindrops to the environment using the sprinklers, and we have the point cloud data from the LiDAR device together with the 4D LiDAR device. And we design an automatic tool that can label all this data. So now we know here where the raindrops are, like those red particles flying. And then this is the original data, and after applying filtering that we propose in our project, you can have this kind of filtered version. So this is the version where we recorded at night, and here somewhere here, that's the version where you have the recording during the daytime. As you can see, we now can get rid of the rain drops. Why is that important? It is important because now you know which points are the noisy raindrops, so you can use this information to mathematically model the noise so that you can transfer this information to your simulator, or you can test your AI algorithms, how they can handle filtering, and so on and so on. So we used for multiple purposes. So we have different cases in the video. You have that. I will skip between different videos just to use time more efficiently. Okay, of course, they will not allow us to jump just so. Maybe I can show this video, which is from Finland, not VTT, but from FGI, where they have implemented a multimodal setup LiDAR together with camera to estimate the slipperiness of the road surface. So they use an optical sensor, or SLR sensor, which is giving you actually a local information about the environment. So on the top, this is a real camera image from the nighttime vision. So you have those local patches. Those are the ground truth coming from this single sensor. Okay. So what they did is they used this information and they trained this. They used this information to train a network that can use camera plus LiDAR to estimate the slipperiness for the entire road surface. And in the middle, you see these estimates only for the road surface. So those are the road segments that are detected through camera image only. And on top, you see the prediction coming from the network slipperiness. I think it's more visible if we go to, the video is very long. I will not run the entire one, but there is a section where you have a daytime vision, where here now the network is predicted some, like if it is yellowish, it is more like slippery for the road part. And you can also estimate the confidence, like uncertainty, how uncertain the network is about its own prediction. So lighter area means like it's more uncertain. It works nicely for region places where you have this ground truth data, but of course, since it is doing extrapolation for the rest of the road surface, it's becoming more uncertain for the remaining part of the road. So the video shows how it works in the daytime, nighttime, and even when falling snow cases, if I'm not wrong. We have also not that one, but that video where we use the V2X communication interactive. So we have a sensor in the infrastructure, which is measuring the, let's say, visibility or slipperiness of the road surface. And it sends a message to the vehicle, which is going autonomously at 50 kilometers per hour. This video is done by VTT, by the way. So now this minimum risk maneuver is triggered. So this is the red path that is estimated by the vehicle, and it changes the path because now it has to have an emergency brake instead of having a emergency stop. So what it does is like has an additional, it computes a new path so that the V2X is pulling the car to a safety zone by reducing the velocity in a smarter way. So this makes like the vehicle more weather aware. If there is any weather-related challenge, the infrastructure can trigger the vehicle to take a different action. We have different videos showing like how sensor fusion works in the infrastructure and so on. And we have also another video from Finland where they show the mapping. They have this kind of environment. This is purely relying on the LiDAR data, but they are using different semantic segmentation. On top, they use small voxels like super pixels, super voxels information, small patches to gain more local information when they do mapping. So they start building map with point cloud instance value. Then based on that, they run state-of-the-art semantic segmentation algorithm, which gives you unique regions in the point cloud. Then they just remove moving objects, dynamic objects, and then they do instance clustering, which is then followed by a primitive estimation like detecting supervoxes for those who know the technical terms. Then they get the cell clusters, and based on that, they have small patches, which keeps a unique local information. On top, they just build map information. And then simultaneously, they can solve the localization. So they have shown this thing on in a scene where it is under snow. Right now, we have recordings where we have also falling snow particles in the scene. And they are going to show this similar thing when you have a slightly different weather conditions. And these experiments will be also repeated in different test facilities in Turkey, in Germany, and so on. Let me see if there is another interesting video that we can share with you. Maybe the last one could be from Ford. We have also a truck here, which is now driving. There is a safety driver. It's not autonomous driving. It's only for logging. They log data under rainy case in Turkey. So you have here a camera view only for sake of visualization. Only thing that we use is the point cloud data. And now you have the bounding boxes for objects, and you have also those red dots. Those red dots are actually raindrops that are detected by statistical algorithms, because on top of in addition to the deep learning methods, we are also investigating statistical methods and the power of that. Of course, they have limited capacity. they are not really super good compared to deep learning algorithms. For instance, they have more or less 30% less performance, but still we are trying to investigate these traditional algorithms as well. So with that, I'm done. I can wait for questions if you have any. In the Q&A, I think there are some questions. Okay, there is a question to me about the slipperings detection. Will this information be shared with road authorities so that they use this for road maintenance? Yes, definitely. So because this video that I showed, let me just run it again. So this information is running real time. So because the training is done offline, and what you need is only this sensor, voice sensor, optical sensor that is measuring the road surface and estimates the grip coefficient for you. The rest is just the training and then running it. And the latency is very low, so it can be run in real time. And this is going to be one of the other demos that we will have later. It will be deployed to another vehicle as well. But we are not right now talking to any road authorities to have interaction and so on, but it is doable, definitely. Another question? If not, then I'm gonna stop sharing. I shared the link in chat for those who are willing to see those videos or even more of those. We will continuously update this link with additional videos later during the life cycle of the project. Right. All right, so that means we are done with the video session as well. Is there any question, any comment, or anything that we are missing that you wanna raise here? And meanwhile, Mario shared a link because, yeah, thank you, Mario. This is the third series in our webinar series. So this is the third one. And after each, we are willing to get some feedback from the participants. So it would be nice if you can share your feedback with us so that we can consider it in the next webinar. If not, I would like to thank all the speakers again. I think I enjoyed it very much. It was very interactive, very productive discussion as well. There are some take-home messages for me as well. Just to summarize very briefly, I will not go through everything that I noted here, but very briefly. So small demonstrations are not enough to attract the public perception of autonomous vehicles. That was one of the comments from Vasilis, but as Marzena said, that CCAM thinks that it's a very valuable feedback. Even if it is a small-scale demo, they can use this feedback as like to reshape the upcoming calls and so on. So it doesn't matter, but of course we have to increase the public awareness. So we have to make it more attractive for the public. Fleet operation should be considered to increase the public perception. Very true. And companies should be more involved because of the cost. And another note, national and international regulations should be revised for the cross-border demonstrations. This was one of the lessons that our speakers learned from their big-scale demonstrations. Not only the part of the EVs should be automated, but also some other external entities in the fleet logistic operation should be automated. That was one of the comments from Loha. I think she's very right. And also the million-dollar question is how to define the safety and how to give the 5-star check to our vehicles when it comes to evaluation and validation of our solutions. Even if you do that, how can you keep the track of those evaluations after the vehicle life cycle? We have to continuously update our validations policies as well. And another nice discussion was around this redundancy in the sensor setup. So how can we define this redundancy? Is there any way to come up with this minimal sensor setup? And collective perception can use sensors from nearby vehicles, like what Vasilios was saying. It is very important to reduce this redundancy. Also, not also from nearby vehicles, but also from the infrastructure. I think it's a very well taken comment. I'm reading my dirty handwriting, so maybe it's not fully correct. AI acts as whatever is there with AI in transportation introduces risk. So we should be careful. That was a comment from Kwan. I really enjoyed that. I appreciate that comment. I think that's a very valid comment. But we have to think about how to overcome these risks or how to reduce the risks. So sensors and AI are intertwined. That's very true. Sensors may not operate well with a high performance without AI. Of course, amount of sensors and amount of this big data, because every day the amount of data is getting bigger and bigger, it's going to be a bottleneck in the future automotive industry. Another comment from Vasilios, I think privacy is going to be another issue. That's very, very true. And for the AVs, I think we cannot survive without infrastructure. V2X is needed to overcome with corner cases. That's, I think, a comment from Kwan. I think we're very right. And of course, we also discuss about what's the next technology to support infrastructure. Is it the 5G or another generations, and how to define these next attractive technologies. I learned a lot. Thanks a lot. I really appreciate these discussions that you guys had all together. Is there any last remark, comments that you want to mention? Because we are coming to the very end. I would like to thank all the speakers again one more time
for their
valuable contributions.
I would like to thank you as well for organizing this event. You might know on 10 of October we have the multi-cluster meeting of the CCAM Association, where we also invite CCAM partnership project coordinators. So feel free to join. Unfortunately, we cannot always give broadcasting time, let's say, to all the projects. So I really appreciate that you do organize this kind of smaller events to also connect with other projects. That's really, really useful for us, for the partnership. Thank you.
Yeah, thanks a lot. And just a comment, yes, we will be there. THI Charisma from Germany will be there representing ROADVIEW. So we'll show our demo videos there. All right, Mario, is there another thing that I'm missing, or I think we are done, right?
Once we're done.
Yeah, after the meeting, we will upload the recording to our webpage and share it with you. Again, thank you very much, and hope to meet you in person later in another event.